Welcome everyone, it's Michael Gibbs and we're back today for day 3 of the AWS Certified Solution Architect Associate 2022 Bootcamp to cover the brand new AWS SAA-CO3 exam. Before I tell you what's going on, I want to make sure you're here. If you have not yet liked our videos, please do so, subscribe and hit the bell to our channel so you get to be informed of all the cool stuff we're doing. Now, while I tell you about all the cool stuff, if you can give me a hashtag AWS Certified Solutions Architect Associate in the chat box, that way I'm going to know you're going to be here, awake, alert, oriented, and ready to begin learning, because I want to get you all hired and I want to have you get all of as many skills as possible. So, obviously, this is day 3 of our AWS Certified Solution Architect 2022 Bootcamp. This is to prepare you for the AWS Solution Architect certification. This is an AWS full course tutorial. It's a free AWS certification training, and it's an AWS certification course. Now, with our free AWS course, you'll get some introduction that'll prepare you for your cloud architect career. I'm sure people will ask me about AWS career tips, which maybe we'll get to 1 or 2. Of course, you can join us tomorrow for the free question and answer session where we'll give you lots of AWS career tips. And like I said, this is to replace the SAA-CO2 exam, the old one with the SAA-CO3 exam. And this is an AWS Cloud Computing full course. So I hope you have a really great time today. A couple of housekeeping things before we begin. Our team has written a fantastic new AWS Certified Solution Architect Associate and Professional Exam Guide. It's a free, full, giant bit book to really get you knowledge that you need and help you pass the exam. The link is completely free. The book is completely free. The link is in the chat box as well as in the description below, so please download that. Because I'm focused on making sure you understand the technology, but we're going to have a discussion where we talk about the technology, but I still want you to get hands-on. So in order to do that, please sign up for the free AWS Labs. Do them on your own time. And that way you'll have access to this book, the AWS Exam Guide. You'll sign up for the AWS Labs completely free. And you're part of our AWS Certified Solution Architect 2022 Bootcamp. All free. And that way we get you kind of going in the direction we want you to, giving you good quality education, and we're giving you as much as we can for free. Now, it costs a fortune to build a boot camp like this, almost as much as a car with the amount of staffing that's required. So tell others, invite others via an email, a text, a tweet, a LinkedIn post to take advantage of our free training. We do this free training to help you all get as much knowledge as we can, and we do it for free. We love to share, so please share this message. Now, if you're looking to transition from AWS Certified to actually getting hired, we have our Cloud Architect Career Development Program. If you're looking to become a manager or become a principal architect or a distinguished architect and you're already an architect, we've got our Tech Career Accelerator Program. If you're looking to interview for a job, we've got our interview program, and everything right now is 30% off until Sunday using the coupon code SECURITY. Sierra, Echo, Charlie, Uniform, Romeo, India, Tango, Yankee, SECURITY. And I'd like to spell it for those of you like me that like to use a phonetic alphabet. So now we're going to get into the fun stuff today. More AWS Certified Solution Architect Associate training. But before we do, can you guys give me a hashtag cloud hired? Other organizations are worried about people passing certifications. Our organization focuses on how to get people cloud hired. So give me a hashtag cloud hired. Like I said, if you've not subscribed or hit the bell, please do so now. Please give the video a like. It signals the algorithm to tell other people to join and get our free training. We want to help as many people as possible get their first cloud jobs. On the break between this presentation this morning and now, another one of my students got a fantastic cloud security architect job, and we couldn't be more pleased. And our whole world is about getting you hired, trained more, and knowledgeable. So kind of keep that in the back. Keith, my good friend, and I'm so happy to see you here today. Thrilled to see you. as well as all my wonderful students and all the other wonderful people from all over the world. Hey, while we're at it, give me a hashtag and tell us your geography in the chat box too. You don't need a hashtag, just tell us where you're from. I'm from Greece, living in Florida. You know, we got lots of people from all over the world here. So give us this, tell us in the hat box. I see some people in Texas. I know we got some people in Houston, Seattle I see so far, Florida like me, Boston, India. I figure we have a lot of people there in India. We usually have people in the DC metro. Iran, I love this. Dominican Republic. We have Cameroonians here, people from Dubai. I used to work there. I loved it. UK, California, and Canada. See, we're all over and we're global, and I absolutely love this. Well, today we're going to talk about my absolute favorite part of the cloud. You know what it is? It's the VPC, or the virtual private cloud. Why? Because it's where we get to do as much networking as possible. And you guys know me, I'm a network person. Back when the CCIE was a complicated exam and it was challenging when it used to be 2 days, I remember taking mine. My CCIE number is 7417, and I love networking. So today we're going to talk about the VPC. Now, under the VPC, we're going to talk about a lot of things, but we're going to talk a little bit about routing, and we're going to talk about much more about routing when we actually go through the AWS Advanced Networking Plus, what you need to know. So we'll talk about that. Then, and it's a little now, but a lot when we do that. We'll discuss internet gateways today. We'll discuss egress-only internet gateways. We'll discuss NAT instances, but also NAT gateways. We'll discuss elastic IP addresses, VPC endpoints, VPC peering, access control list, security groups, and we'll have some more fun as well. But I want to begin with, let's begin with the routing tables. What is a routing table? Well, it's really a map of how your traffic gets to its destination. And routers build maps. The way routers typically build maps is they run a routing protocol inside the network. It's called an interior gateway protocol. Typically speaking, in today's world, it's using something called OSPF, or intermediate systems to intermediate systems. Routers identify with each other and they tell each other the state of their routes. When we connect to external entities, we use BGP, and I'm going to show you graphically what that looks like. And it builds a table that says, how do we get from point A to point B? What's this table look like? It looks like this. To reach Joey, go out my right arm. To reach Nick, go out my left arm. To reach Sally, go north. To reach Blake, go out my leg. So it's basically building a table. Now, I built a routing table for you in Excel just so you can get a feel for it. And it's going to look like this. The routing table is going to tell you the destination subnet and where to send it. Now, when it comes to .routing, we're talking about the most specific route. And if you notice, I have two routes, which are very similar. I've got the 192.168.0.0/16. And I also have the 192.168.1.0/24. For those of you that know subnetting and supernetting and route summarization, you're aware that 192.168.1.0/24 falls within the 192.168.0.0/16. But which one's more specific? The one with the longer subnet mask, the 192.168.1.0. So if we want to reach the 192.168.1.0, we're going to end up using the interface PCX-654321. But if we want to reach any other subnet inside of that range, we're going to use the interface PCX-123456. And of course, we have a default route. What does a default route mean? If you don't know where to go, take the default route. And here you can see we've got a default route pointing to an internet gateway. And there you go. So that's realistically what we're talking about. Now, the VPC has a routing table, but let's talk about what they really look like in real life. Let's assume on the left side of this is 64513, This is your entity, your data center. And let's assume for right now, on the right side of this, we've got the AWS cloud, the Azure cloud, the Google cloud, your other data center, another company. It doesn't matter. It's all the same way. Now, inside of your data center or the AWS cloud, they're going to have to calculate the routes in between their stuff. And that's used with an IGP or an interior gateway protocol. We'll discuss them much more when we cover the AWS Advanced Networking. But for right now, understand, inside of an organization, routers have routing protocols that determine the best path for the traffic. Kind of like your GPS does. When you go to somebody's house, make a left, go 2 miles, make a left, go 3 kilometers, make a right. Kind of keep that in the back of your mind. Now you'll note that we have where it says eBGP peering between the two organizations. Now, BGP is a path vector routing protocol that's used to connect to external entities. So when you connect to your cloud providers, they are not your organization, they are an external company, and you're going to use BGP. Now, we're going to be using BGP to exchange certain information. I'll talk about what that is, but understand, internally, all organizations have an interior gateway protocol, and in between them, they use an exterior gateway protocol, which is BGP. And when you connect to AWS, you are going to be using BGP to exchange routing information, especially if you're using a direct connection will be required. And if you're using a VPN, you could use BGP or create a static route, but you're going to want to use BGP because otherwise you're going to be manually updating routes, and that is a nightmare. I can't get into a full BGP discussion here, but I can tell you this right now. When we do the AWS Advanced Networking coming very soon, I will spend hours on BGP, hours on subnetting and supernetting. We'll spend time on interior gateway protocols. We'll spend substantial time on switching. And then we'll cover the silly, easy AWS Advanced Networking, which is honestly an intro to junior level networking. We're going to add that critical networking up front so you guys understand it because it's critical knowledge. So let's talk about a little bit about dynamic routing with BGP. BGP is the de facto standard exterior gateway protocol. And because AWS, Azure, Google, you connect to them externally, you'll be using BGP to connect to them. Now, the reason we use BGP as opposed to an interior gateway protocol is as follows. The tunability of it is incredible. The scalability of it is incredible. When I connect to 3 different internet service providers, with BGP, I'm taking in about 800,000 routes per internet service provider. I mean, it's incredibly there. So it's scalable. Whereas interior gateway protocols like OSPF kind of die once you hit 30,000 subnets or so. And there's lots of tuning and manipulation. Plus, we can't filter routes between us. And BGP gives us the ability to filter routes. And why does this matter? If you don't have a path to it, you can't reach it. So let's say I've got a buddy over there in England. I got lots of friends in England. And here I am in South Florida. Now, if there's no airplane and there's no bridge, I couldn't visit my friend. There's no route. So with BGP, you can provide the path that you want people to access, and you can provide no route to the path that you don't want to access. Now, how would I get from Florida to England? Well, I could try and swim, but that's not going to happen. I'm going to run out of fuel and be eaten by sharks. I need a path. I need a route. And BGP provides the path. It provides the routes, the knowledge, intelligence on how to get your data from point A to point B. Now, when an organization wants more than one connection to the internet, like 2 of them, they can either have one default route and a backup default route, in which case they use one and the other one sits there sleeping, or they can use BGP and they can load share. So BGP enables you to load share, traffic engineer, and tune your data. It's magical. I spent over 10,000 hours learning BGP and working on BGP, and trust me, people like me that are network architects can do really cool stuff with this. And if you want to be a great cloud architect, you must be able to understand BGP. Otherwise, your systems will fall apart. So we'll cover that in more depth with the AWS Advanced Networking. It's not covered in the AWS Advanced Networking, but we'll cover it anyway, and we do that completely free. Now, when you use BGP, you kind of have to identify yourself. So, basically saying, hey, yo, I'm Mikey. Yo, Joey, let's be friends. And that's really what has to happen. You actually have to connect to each other, identify yourselves, and set up your policy. So like I said, when you use a direct connection to AWS, you must use BGP. Now, BGP's got a lot of tuning things. When we cover the AWS Advanced Network, we're going to get deep. We'll prepend ASs and leak specific prefixes and change the weights, play with the local preference. It's going to be party time, party time, party time. That's about the only time when I talk about networking where I get to put my propeller hat on and get real geeky anymore, and I love it. Because I started out as a techie. It's just that I can't be a techie as an architect. I got to be a business executive. But when I talk about BGP, put my techie hat on, and it's fun, fun, fun. So, well, one thing we'll talk about is AWS supports the BGP community no export. I'll show you what that means in a second. The AWS BGP implementation supports the proprietary weight, which is great because lots of other routers do too. Local preference, AF pass, specificity of routing information. So it's a pretty standard BGP implementation. But AWS only allows you to inject a very small number of routes, like 100, which is 0. It's basically nothing. So when you're going to be connecting to AWS, you better have somebody that understands IP addressing, subnetting, or supernetting. So you can use summarize and route aggregate. Now, let's briefly talk about what no export means. So normally speaking with BGP, let's say you've got 3 of us that want to talk to each other. We've got my data center, my superstar architect, cloud architect Chow, Alonzo, also from my team, my chief content officer on our team, and we want to exchange information between us. In a normal environment, if I connect to Chow, and now Chow collects to Alonzo, I know how to reach Alonzo through Chow. Alonzo knows how to reach me through Chow. So what happens is Alonzo's traffic wants to reach me, and here's what will happen. It'll go through Chow to me, and then I'll respond, and here's what ultimately is going to happen. I'm going to respond back. My traffic will traverse Chow and go through Alonzo. And we're all happy, right? Because we've got routing. But here's the problem. What if Chow doesn't want to be the entire destination for the entire internet to connect me through Alonzo? Well, what would happen, and to make this simple, is we tell Chow our routes, and Chow doesn't tell anybody else our routes. So if by comparison, I tell Chow my routes, and Alonzo tells Chow her routes, his routes, loop this around, and Chow tells me her routes, which are not putting the arrow, and I tell Chow my routes, I can reach Chow. Now, if Alonzo tells Chow her route, his routes, and then Chow tells Alonzo her routes, they can talk to each other. But if Chow doesn't send Alonzo's routes to me, I can't reach Alonzo. And that's typically done via a BGP community called no export. There's many other ways to do this, but AWS does support that no export community, so kind of keep that in the back of your mind. All right, so we had a little introductory to BGP. We're going to do it a lot better in a lot more depth when I actually have 4+ hours to do it when we do the AWS Advanced Networking. Like I said, it's not covered in AWS Advanced Networking, but we're going to cover it because you need to know it. So how do you get to the internet? Well, you need a router that connects to the internet. Now, what's the alternative name for a router? It's called the gateway. So this is one of the few places where AWS didn't have their marketing people spend millions of dollars to create a fancy name that doesn't mean anything to anybody. An internet gateway, what do you think it is? It's a router that takes you to the internet. I love this name because it's reality. And an internet gateway is going to be a virtual, because it's a cloud, it's all virtual, router. And because it's a virtual router, not a physical router, it can't go down. So this is going to be a highly available internet router. Now, AWS for certification points will tell you there's no bandwidth constraints or performance limitations. Look, there's always a bandwidth constraint or performance limitation, and you'll have to figure that out as it takes to testing your applications. But at the end of the day, the internet gateway is nothing more than a router that connects you to the internet. So the way you create an internet gateway is a very simple thing to do. is you attach an internet gateway to your VPC. You create a default route, which looks like 0.0.0.0/0, pointing to the internet gateway. You put a public IP address on the internet gateway. Why does it need a public address? It's going to reach stuff on the public internet, needs a public address. And there you go, you're good. Now, here's the thing to remember. You've used an internet gateway. Now your stuff will be accessible from the internet. Now, if your stuff is accessible from the internet, and you don't do something about it, you'll be hacked in about 15 minutes. So when you're connected to the internet, you're going to need to do some serious security things. Otherwise, you're going to get hacked. So let's look a little bit about what this looks like, at least in concept and principle. Here you can see we've got our stuff in our VPC. Where we have the term instances, you can think about them as maybe a web server, an FTP server, whatever you want, reachable by the internet. The instances all need to have a public IP because they're not behind a load balancer here. And the internet gateway needs to have a public IP. And there you go. Our systems are going to be reachable through the internet, and people can attach to our web servers, FTP servers, or any other kind of server we want to put there. Everybody's happy. Let's say we've got a cat. My cat Cindy made a website, www.cindythecat.com. She puts it on some of these servers, and we got photos of my cat Cindy dancing, my cat Cindy sleeping, my cat Cindy climbing the walls, sitting on the roof, running away from her scary friend, the Maine Coon, which is a beautiful cat that she doesn't like, so she hides on roofs when the cat comes, and it's all on her website. So kind of keep that in the back of your mind. Now your systems are available from the internet. Now let's talk about something different, an egress-only internet gateway. So let's talk about this. Ingress is traffic coming in. Egress is traffic going out. When this was first explained to me, it never made sense. So I like to think of it as a parking lot. When you enter a parking lot to go to your favorite pizza place, that's ingress. And after you had your pizza and you're full, and you leave that parking lot, that's egress. So let's talk about egress-only internet gateways. They allow your IPv6 traffic, not IPv4, which is 99% of your traffic, to go out to the internet and have stuff come back to them, but not be reachable from the internet. So why on earth would you ever want egress-only internet traffic? Because it sounds crazy, right? Well, it's not. So let's say you want all your systems secure behind the firewall so nobody can come into them. But you want your systems that are behind the firewall and your users to be able to go out to the internet, to go buy training from www.gocloudcareers.com. And then you want them to go to www.cindythecat.com to look at some cat photos. And then you want your person to be able to Google something. And then you want your systems to be able to update their operating system from Red Hat, Ubuntu, Microsoft, or whatever. That's where you need egress-only internet access, where you want your systems to go out to the internet, be able to do something, allow the return traffic back in, but not allow other traffic to come in. So that's what we're talking about when we talk about an egress-only internet gateway. It's for IPv6. It enables the traffic to go out to the internet and come back. But your systems are not reachable. So how does it work? Well, it's stateful, just like a firewall. Traffic goes out, comes back. Other traffic externally tries to come in, blocked, blocked, blocked. But here I am, and I want to go look at my, Facebook account where I've got cat Cindy photos. I don't have any cat photos on Facebook, but let's say I want to go to my Facebook account. I would go through the egress-only internet gateway, and when the traffic comes back from Facebook, it would hit that egress-only internet gateway, which acts like a firewall here, and says, yep, Mike requested it, send the traffic back to Mike. So no inbound activity, traffic out, traffic back. Used for IPv6 systems to go out to the internet and come back. Now, we're going to talk about a NAT instance, which was kind of an AWS managed service. which has been sort of, we don't recommend you do this anymore, but there's still times where you're going to need to create these on your own. So let's at least talk about what it is. A NAT instance is basically a system like a virtual machine that's got 2 Ethernet cards in there that translates a private address into a public address. Now, this was available from AWS as an AMI, so basically a systems image, and it runs on an EC2 instance. And in this particular case, NAT is only going to the internet. So you have to put part of it in a public subnet and part of it in a private subnet. And what happens is, and I'll show you later, NAT instance will then translate your private addresses to a public address so they could go out your internet gateway. So no inbound internet access. And the way this will work is as follows. Let me draw you a picture. You would keep your systems in a private subnet. You would create this NAT instance, which is just a virtual machine with 2 or 4 network cards. This NAT instance would do something called NAT overload, otherwise known as port address translation. And it would translate your private IP addresses into a public IP address. Your systems would have a default route to the NAT instance. The NAT instance would have a default route to the internet gateway. The NAT instance would have an external IP address. The internet gateway would have an external IP address. And all your systems would have access to the network, the internet. So that's a standard AWS NAT instance. Now, what if you wanted to translate between 2 IP addresses? Well, you could obviously create a Linux machine on your own, put 2 Ethernet cards in there, and translate between a private address and another private address. And why might you want to do this? Well, let's say I addressed my system 10.0.0.1, and I bought a company who addressed their system 10.0.0.1. Wait, they can't talk to each other, but if we NAT between them, then we can. So there's lots of use cases to use NAT. These are only the ones that we're mentioning. Now, if you notice that NAT instance required an internet gateway to work. So AWS likes to make people's lives simple. The whole point of the cloud is it's simple. We lose features, we lose functionality, we lose performance, but it's simple. We go to the cloud because it's agile, it's fast. We don't need as much sophistication because they manage 3/4 of the workload for us, which is kind of beautiful. That's why we all love it so much. So AWS came up with a simpler, more elegant solution for most people. And it's called the NAT Gateway. And the NAT Gateway kind of combines the NAT instance and our internet gateway in the same device. So a NAT Gateway is a fully managed NAT service. A NAT Gateway is redundant inside of an availability zone. Every availability zone will require its own NAT Gateway. So what happens is you create the NAT Gateway in a public subnet. It will have an an external public IP address, which AWS likes to call an elastic IP for the life of the gateway. You'll put a default route on your systems to the NAT Gateway, and then your systems can reach the internet, and then your traffic come back, but they will not be reachable from the internet. Remember, this is egress only, just like the egress only internet gateway, except for the egress only internet gateways for IPv6, and this is for IP version 4. Simple stuff, simple stuff, simple stuff. So let's look at this under the concept of what we're doing here. You can see here we've got our systems in a private subnet. We've got our NAT gateway, and they can go to the internet. But remember, our systems will not be reachable from the internet. Our systems, our servers can go out there and update their operating system, collect new operating system patches, and all kinds of good stuff. Go through the firewall and get out to the internet. And our traffic can come back. Simple, elegant solution. So now let's talk about the Elastic Network Interface. This to me is the most ridiculous name in the world. When you have a server to connect it to the network, you plug it into its Ethernet card. When you have a virtual machine, guess what? It's got an Ethernet card in it, a virtual one usually, although it could be a physical one if we talk about single root IO virtualization, which I'm sure we'll address soon. But what's going on is if you ever want to put your virtual machine connected to the network, you need an Ethernet card. So what does AWS call the Ethernet card in your virtual machines? They call it an elastic network interface. So by default, your systems come up with a single elastic network interface. But if you want two systems to be on two different subnets, well, then you could use two of them. Now, in many certifications, they teach you how to create something called the bastion host, which is about the fastest way to get hacked, fastest way to get fired. So I'm not going to teach you how to do that. There's a way to do it intelligently, but 99% of them that I've seen out there are hacking events. I've seen people get fired for putting these things up there, so I'm not going to teach you how to do that because I don't want you getting fired. I know they teach that in a lot of certification courses, but there's good reasons not to do it. We've got a video on why you should never create a bastion host, and my team can pop that in there. But if you had a server that you wanted to have on two different subnets, you could put two network interfaces in there, and that's what we always used to call a dual home server. Now, we can have a management subnet on one side versus another side, inside, outside of our network. So there's lots of reasons we might want to do these things. So let's talk a little bit about elastic IP addresses. Okay. Now, AWS could just say public IP address, and I'd be happy, 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 right? But, they don't. If you want a public IP address from AWS, they have to stick the word elastic in everything. And because they have to stick the word elastic into everything, they call it an elastic IP address. It just means a public IP address. So here's how normal you would get a public IP address. You've got a network architect like me. I need a public IP address. I go to my ISP and I request one. And I own it until I'm done with them. Now, by comparison with AWS, when you need a public IP address, you get one of their elastic IP addresses. They own the address. They give it to you for as long as you need it. And when you shut your system down, it goes back into the pool, and they can go and resell that IP address to somebody else. An elastic IP address can have a single public IP address mounted to it, like at the edge of a load balancer, or it could be used in a NAT overload situation, like you would in a NAT gateway, which provides port address translation. A little bit of an appearance of what's an elastic IP address look like. Very, very simple and elegant. Very simple and elegant. Here we go. We've got our private systems. We've got our instances, which are sitting behind the firewall, all using the public IP address, otherwise known as elastic IP address, 3.3.3.3. Goes out to the internet, and we should be good to go. Pretty simple and elegant. So let's get into the next thing. Actually, Chris, how long have we gone so far? Have we done more than 20 minutes?
We've been going for almost 30 minutes.
Okay, let's take some questions.
All right, and as a reminder of everybody, we will be addressing questions that are only related to the content that's being covered. We will not be addressing any career or career training questions during the boot camp.
At what level is BGP implementation? Security group, NACL? Is this an application or network layer? Okay, BGP is a routing protocol, which by default makes it an application layer protocol. Having said that, it's being used to exchange network layer reachability information, which is layer 3 information. It is way, way, way outside anything related to a security group or an access control list. The only thing that they would actually have to do with is if you have your BGP peering session progressing through a firewall, which it will be, a security group and an access control list, they need to be open to TCP port 179 to allow the BGP traffic to go through that. That's the only way they're related. BGP is a routing protocol. NAT instance is egress only related to traffic flow. Absolutely. When would you use a NAT gateway as opposed to an internet gateway? Very simple. If you want your system to be reachable from the internet, you need to use an internet gateway. If you don't want your systems to be reachable from the internet, but you want them to be able to go out to the internet, and you want them to be able to connect to the internet and come back, then you need, so if you want your system to be reachable, you need an internet gateway. If you don't want your system to be reachable, but you want them to be able to go out to the internet to say update their operating systems and come back, that's when you use a NAT gateway. Good question. Can I go over the rule no export again? Lady Godiva, absolutely. Let's say, Lady Godiva, I tell you about my cat Cindy, and you've got a friend. And I say, don't tell your friend about my cat Cindy. That's no export. So no export is I send you routes and you're not allowed to tell them to anybody else. And because you can't tell them to anybody else, nobody else can reach me through you. Good question, Lady Godiva. When do you use Ingress and when do you use Egress? Ingress is used when you want people to be able to reach you. Egress is used when you don't. You only want to be able to go out. Please explain how implementing a Bastion host is a security risk. Sure, I'll do that right now. I will show you why if you implement a Bastion host, you will be fired in your first 24 hours. So here's what a Bastion host really is. You've got the public internet, which we'll put here as a cloud, big scary cloud, and on the public internet there's a million hackers.
Are you sharing your screen, Mike?
Oh, thank you. So here we've got a public internet, and here we're crazy enough to put a virtual machine, like a Windows virtual machine. We put a virtual machine directly on the public internet. Now this virtual machine has two network cards, and one of them is related to the private subnet where our web stuff is. Oops, I didn't mean to do that. So now we've got a public internet, and here's how you directly reach our systems. So now you've got a virtual machine, say it's a Windows machine, which is not secure at all, or we've got a Linux machine, which starts off offering thousands of services more than you need. And now that's directly how you bypass our internal network. And nobody would be crazy enough to do this unless all they saw was a certification exam. Now, what's the alternative to this? Well, the alternative is you would have the internet, and this is how real businesses do it. All businesses, by the way. Now, Azure has a different kind of Bastion host service, which is a little different. You would have your internet, you would have your what do you call it, your internet. And then what you would have is typically a network load balancer. And the reason you're going to have a network load balancer is we're going to need real security. So we're going to need some next generation firewalls. And if it really matters, like for real, we're going to have another load balancer and another set of next generation firewalls from another company. Because if you pack through the Cisco firewalls, you're probably not going to be able to get through the Palo Alto firewalls. So we're going to have two sets of firewalls. And then what we're typically going to do is we're going to have an access control list. And then we're typically going to place a very specially hardened machine back here, which is called the VPN concentrator. And the VPN concentrator is made by a security company like Palo Alto and Cisco. And this VPN concentrator is going to allow only one service, such as IPsec coming in. So what we would, I didn't mean to go back to here. So what we would have is the traffic would have to get through the load balancers. These firewalls would only be open to IPsec traffic. Then we get through another series of firewalls that's only open to IPsec traffic. Then we'd have another subnet, because these are all going to be on different subnets, so we can use ACLs between them. And the ACL would block all traffic but IPsec. And then we've got the specialty hardened VPN concentrator. And then after the VPN concentrator, that's when we have our systems. So here you're dealing with some serious, serious things. And what's the difference between Billy Bob making a Bastion host and thinking he or she can harden an operating system? Is one person most likely won't know how to harden the operating system. The operating system on this VPN concentrator that we're talking about is going to be done by a company like Cisco or Palo Alto or Fortinet or Checkpoint. It's going to be, they're going to spend, $500,000 securing this operating system. They're going to have a QA tested by, thousands of people. And that's all they do is make security appliances. Now, if you wanted to create this environment and stick your Bastion host there instead of a VPN concentrator, it would be less bad. But typically what Bastion hosts is for 99% of the companies, or as it's taught in certifications, is here you go, here's your thing, now here's your virtual machine with 2 NICs. Here's your typical virtual machine with 2 NICs, VM, and now here's typically your internal network. And that's why this is really, really reckless. Now, there is an option on how you can make a secure Bastion host. And the way you could make a secure Bastion host is you could do as follows. You could create this load balancer, have your 2 next generation firewalls, have another load balancer with another set of load balancers, have an access control list, have your VPN concentrator, and then you could put a secure Bastion host that's over here. And in order to do this, what we would then do, let's move this stuff over. What we would then do is we would have, and this is totally feasible for you to do it this way, but this is not what's taught in the certification. You could have another, you'd create a subnet where your Bastion host is. You could put an NACL here, and you could put a security group here, and then you could put your Bastion host back here. This would be safe, but that's not what's taught in certification. Let me get back to the other questions. Can I explain an elastic IP address? Here's the thing. It's just a name that AWS calls a public IP address. So if you need an address that's a public IP address, it's an elastic IP address. We address this. The route table has multiple routes next up in case the optimal router goes known. I've seen so many, you need a routing table with multiple routes for this reason. If you've got 30,000 remote locations, each one of them is going to be in a subnet. So we need this. And it's there. So, kind of keep that in the back of your mind. Why do you need multiple paths? Well, one router is going to die. Imagine trying to drive someplace that's 10,000 miles away and just planning out your path. Step 1, drive for 1,000 miles, go left for 1,000 miles, go right for 1,000 miles. Do you think you'd reach your destination? Or do you think there'd be a roadblock by a storm or the police or something like this? So that's why we need this. And if your network's designed properly, your systems will reroute. The key is knowing how to design your networks properly. Is the routing table manual or set up? It depends. If you use static routes, it's manual. And every time you make a change, you're going to have to manually change it. And if you don't remember to make a change, your systems are going to fall apart. Or if you understand dynamic routing, you use dynamic routing. Here's the thing. Understanding dynamic routing, by the way, is about 10 times harder than understanding all the curriculum in a certified solution architect professional. And that's why cloud architects and network architects and solution architects need far more than's covered in certification. What is a VPN concentrator? A VPN concentrator is basically a device that enables you to connect to for remote access employees. Does network trunking work along OSPF? They're entirely different technologies. A trunk is layer 2, which is related to switching, which is putting multiple VLANs on a single link. And OSPF is related to how to build a layer 3 map of your network. They're totally unrelated, but I will cover them in the AWS Advanced Networking course. And I will address this. They don't teach there. There's 2 questions I'm going to address. One is they don't teach Bastion host in real training. They teach it in Udemy courses and certification courses that are being taught by non-real architects themselves. It's not taught. If you went to Cisco, they would not teach you how to create a Bastion host. If you went to a university, they would not teach you how to create a Bastion host. It's only taught by people that are doing certifications that don't know. And the other question that I wanted to address was ARISes real quick. It feels like a lot to learn. Yes, Egress, it's going to take a lot to learn. That's why our Cloud Architect Career Development Program is 500 hours and not a 20-hour certification course. You need to design things, get feedback on designs, design them some more, get feedback on designs, design things, and get feedback on them more. Once you do it enough, it feels just like second nature, just like AJ mentioned in the chat box. Good job, AJ. Thank you for that. So if you guys can give me all a hashtag that says AWS Certified Solution Architect Associate in the chat box, I know you're awake. I need to know you're awake. I'm teaching here with laryngitis to try and make sure you guys have a good learning experience, and I want to know you're awake. So now let's talk about VPC endpoints. VPC endpoints are essentially devices that are high availability and enable you to connect to things. There's two kinds of endpoints. There's gateway endpoints and there's interface endpoints. Let's first begin with gateway endpoints. Gateway endpoints are high speed, high security access to AWS services. And what happens is it places a route in your routing table. And gateway endpoints are typically to things such as Amazon S3. And what happens, it'll put a route in your routing table and it'll reach AWS S3. So you'll create an endpoint, it's going to create a prefix list, and it'll attach you to the endpoint. The reason we're using the endpoint is it's going to provide secure access. Let me show you what it would look like without the endpoint. So let's say we were inside of our VPC, our virtual private data center, and we wanted to connect to Amazon S3. There's really two ways that we could do it. Way one would be to go all the way out to the internet, cross the internet, and come back to AWS and reach our S3 bucket. Now let's talk about why that's ugly. Well, we have to go to the internet, and that's outbound traffic. And guess that one, we're going to pay for all that traffic to go to the internet. Now the internet is not secure, so we're going to have to encrypt that traffic. Then it's going to come back in. So cost is a reason we don't want to do this, but the internet is not guaranteed, has no guarantee, so the performance of the internet isn't good, and the internet's not secure. So now we have to encrypt it. So let's think about the alternative way. If we didn't want to go to the internet per se, and we just wanted to use the AWS private network, a network with guaranteed speed, guaranteed performance, and guaranteed capabilities, we could just send our traffic directly over the AWS private network, and that's what the endpoints are for. Endpoints provide secure, private, high-performance communication, and now gateway endpoints are to reach AWS services like S3. So let's talk a little bit about gateway endpoint security. We can set up an endpoint policy that can be set up to limit resources, like to the S3 bucket. We can limit routing information so that not everybody knows about the endpoint. If you don't have a route, you can't reach it. It's some of the best security in the world. And we network architects and network engineers were providing security for decades. And here's what we're doing. It just didn't give somebody a route. If they didn't have a route, they couldn't reach it. And then we would use access lists, firewalls, and all these other cool things. But first part of security is don't give somebody a path to you. So if you wanted to build a really secure house, right, and you created an island in the ocean, and you needed a boat or a helicopter to get to you, it would be more secure than if you built your house in Philadelphia, for example. I'm from Philadelphia, pretty high crime area, so I can tell you right now, if I had a house in the middle of the ocean, it'd be less likely to get hacked than if it was in Philadelphia. So keep that in the back of your mind. Now let's talk about the next kind of endpoint, the interface endpoint. Now, interface endpoints are a way to connect to several AWS services, like EC2 Systems Manager, Kinesis for streaming data, Elastic Load Balancer APIs. or external services hosted by AWS partners or other customers in their own VPCs. Now, an interface endpoint is going to work differently, and it's really kind of cool, actually. Basically, what's going to happen, now if we had a gateway interface, what happens to the previous kind, it puts a route in the routing table. Now here, when you create an interface endpoint, it effectively puts another network interface or an elastic interface on your VPC. And your interface is local to the VPC. And when you create this interface endpoint, AWS will create this network interface in your subnets that you want to have access to this, which is going to be pretty cool. And then when you create the endpoint, AWS will automatically generate a fully qualified domain name so people can connect to it via domain name. What's a domain name? mike.gocloudcareers.com. That's a fully qualified domain name. And it's going to give you something just like that. Another really cool point of interface endpoints is they use a service called AWS PrivateLink. Look, I love PrivateLink. I've been working with the equivalent of PrivateLink now for 30 years, well, 25 years. Feels like 30 and dog years, so to speak, because I've been doing it forever. And PrivateLink is basically what's called a virtual private line. And what is a virtual, and it's going to restrict all traffic between the virtual private line. So let me draw it out what a virtual private line looks like for you. Because, if you're not used to private lines, then you're definitely not going to be used to virtual private lines. Let's go back to my fancy drawing board. So let's say you've got, we used to call it the frame relay cloud. It could be the internet cloud. It really doesn't matter. So we've got us over here, our VPC, and we want to connect to somebody else's VPC over PrivateLink. Now, realistically speaking, there's two ways we could do this. Option one, we could connect to the internet and back to the internet, and woohoo, everybody's talking to each other. Now, we have to understand that by doing this, we've got internet security issues, and the performance of the internet is not guaranteed. So we have no guarantees that the internet are there. But what we could do instead is, if this is the AWS private network and they control the private network, AWS, what they can do is they can create us a virtual private line directly across it. And we'll call this PrivateLink. And it's basically a pseudo wire, a fake wire they're creating for you. It's no different than an MPLS TE tunnel, a GRE tunnel across a private network. They're building you a private wire. So they're giving you much better access to their own network. The reason we can't control our traffic on the internet is our traffic goes to 10 or 12 different entities. But when it comes to PrivateLink, we're only using the AWS network. And you can guarantee performance across your network using signaling, things like resource reservation protocols, things which you don't need to know about for this. But we can't guarantee performance across the public internet. And this is when you're already on your systems. Not, for example, if this was a direct connection getting to AWS. So let's say we're doing this. Let's say we've got a VPC over here to the left side of the screen, another VPC. We can basically create a private link connection between us, and everything is done. This is done internally. This is the equivalent of a pseudo wire, and we're good to go. I didn't share, let me share this photo with you. So in this particular case, we've got a service customer, and we've got a VPC, and we're creating that pseudo wire in between them, and that's the way they can talk to each other. Very simple, very elegant solution. Very elegant solution. Now, there are other ways to get our systems to communicate to each other. And the other way is VPC peering. And I'm going to get into VPC peering in a minute. But before I do, I'm going to give you some backup information about the difference between PrivateLink and VPC peering. PrivateLink is only going to allow you access to a single service. So I can create a PrivateLink connection, and I can only give people access to the Cindy.com website and nothing else. My cat Cindy, she's pretty popular these days. She's like internet famous because she's always doing fun stuff. So access to just Cindy's beautiful photos of her doing silly cat things. By comparison, VPC peering is a little different. I have my VPC, I connect to SuperChal, the amazing cloud architect VPC, and she and I can exchange everything between us. So PrivateLink, I give Chow access to just Cindy the cat photos, and she's happy looking at my silly cat Cindy. But now I want to connect to Chow, and I want to share information. I use VPC peering. We're going to get into VPC peering in a minute, but when you use VPC peering, every organization must have private addresses. I mean, must not have overlapping addresses. So if I'm using the 10.0.0/16 space, and Chow is using the 172.0.0.16/16, 172.16.0.0/16, yeah, and we have different addresses. Chow and I can use VPC peering, and we're all kinds of happy. Well, what if Chow, my super architect, and she's an amazing architect, read RFC 1918, and I read RFC 1918, and we decided to both use 10.0.0.0/16 on both of our systems, and now we've got overlapping IP addresses, much more common than you think. Now my systems and Chow's systems are not eligible to use VPC peering because VPC peering does not work with overlapping IP addresses. Now, when we've got overlapping IP addresses, our systems can't talk to each other. No big deal for we network people. We just use NAT to translate between them. But VPC peering doesn't let you use NAT. So when you need to deal with overlapping IP addresses with organizations, which is extremely common, because all organizations use RFC 1918 private address space, PrivateLink automatically does NAT. So we'll keep that in the back of the mind. Now, VPC peering, which we're going to get to in a minute, enables you to connect to other virtual private clouds or virtual private data centers. But you can't get more than 125 connections. That's nothing. That's like zero. Me then, deep with the butt piss, as my grandmother would say. Nada. Zilch. Nothing. Where PrivateLink gives you much more scalability. PrivateLink, they'll tell you the limits are based on the max throughput achieved by your load balancers and servers. There's some other stuff beyond that, but for your test, PrivateLink's limits are only based upon the limits of your load balancers and servers. One last thing, Chow and I have VPC peering between us. She can get access to all my information, and I get access to all her information, and it's unidirectional. I could set it up where Chow could only see photos of Cindy the cat, and I can't even reach her. Whereas with VPC peering, it's like opening a full conversation between two people. Both sides can get access to everything. So now let's talk about what is VPC peering. VPC peering is simply a means to connect two private virtual data centers to each other. Now, VPC peering provides a non-transitive connection, and we'll do some demos and explanations here. What is non-transitive? It means if I connect to Chow, and Chow connects to Alonzo, I can't connect to Alonzo through Chow. I can just connect to Chow, and Chow can just connect to Alonzo. That's called non-transitive. VPC peering always uses private IP address space, and inter-region VPC peering, meaning going from like the US region to a UK region or an Asia region, is encrypted. Let's look at basic VPC peering, and then we'll talk about some challenges and workarounds. This is normal VPC peering. I've got one VPC, I've got another VPC, and we do VPC peering between us, and we can exchange organizations, information. Now, it's common to have a lot of VPCs. You might actually find 1,000 VPCs in your own organization, let alone external organizations. And here's the reason why. In my data center, I can do beautiful micro-segmentation. I can create different subnets for different systems, and I can route between those subnets and put ACLs between every subnet or access control lists. Very simple and elegant. In my VLAN, I can do rate limiting, admission control, and all kinds of cool stuff. Yes, I have greater security in my data center than the cloud if I design it right. I don't have access to any of those cool security features in the cloud. None. So sometimes the only thing that I can do in the cloud is to chop my company into multiple virtual VPCs, multiple mini organizations, and then use BGP and routing to connect between them. This is some of the complexity that we're trying to do in the cloud to try and equal the security we naturally had in our data center 10 and 15 years ago. So we're going to be dealing with a lot of VPC peering. Now, as I mentioned, VPC peering is not transitive. I'll explain what that means, which means you've got two options: hub and spoke and fully meshed. Now, if anybody wants a funny math challenge, I want you to understand why 125 VPC peering connections is dipata, nada, zilch, zero, even, zaba, bupkas, whatever you want to call it. The formula for determining how many VPC peering connections you're going to be is n times n minus 1 divided by 2. I hate math, so let me explain this to you. If we've got 3 VPCs that we're going to peer, and I'm going to show you this in a minute, it's simple. 3 times 3 minus 2, n times n minus 1, so 3 times 2 equals 6 divided by 2. We've only got 3 peering sessions. Simple, 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 right? Now we've got 10 VPC peering sessions we need to do. So 10 times 9 is 90 divided by 2 is 45. Wait, only 10 VPCs? What about organizations that have 1,000 VPCs? So 25 VPCs. 25 times 24. Now you're getting there. Divide by 2. See, we've already exceeded the 125 peering sessions that we're allowed to do. So let's talk about hub and spoke, when you'd want to use it and when you wouldn't want to use it. So let's first talk about an environment where we want everybody to talk to everybody. Here we go. We've got 3 VPCs here, A, B, and C. A is on the bottom, B and C are up top. Because we have VPC B paired with VPC A and C, VPC B can talk to A and C. Because VPC C is paired with A and B, VPC C can talk to B and A. And because VPC A is paired with VPC B and C, VPC A can talk to B and C. So here we go, everybody. Now everybody's talking to everybody. Pretty simple, right? Simple, easy. But what if we didn't want everybody talking to everybody? Might that occur? So now let's pretend I'm a computer manufacturer. And I want to connect to other organizations. Perhaps I want to connect to a DRAM manufacturer. Let's call them VPCB. And an NVMe drive manufacturer, call them VPCC. And a CPU manufacturer called VPCD. And an SSD manufacturer called VPCE. And a GPU manufacturer called VPCF. And another GPU manufacturer called VPCG. Now, do I want my 2 GPU manufacturers, NVIDIA and AMD, talking to each other through me? Of course not. So here's a perfect place where I can do hub and spoke. By doing hub and spoke and having non-transitive routing, I can connect to everybody, but they can't connect to each other through me. So here's where security is good. But now, what if I want everybody to talk to each other? For example, what if I wanted B to be able to talk to C through A and D to connect to A through E and A to connect to C? Well, I've got 2 options. Option one is I fully mesh them, but as I told you very quickly, we're going to get through those 125 peering connections very quickly. Option 2, I break the rules. And there's 2 ways where we can break the rules over here. Our rule-breaking options are something called Transit Gateway and CloudHub. For the certification providers that are going to make it sound very different. For the people that build their clouds and know networking, they're pretty much the same thing, and I'm going to show you the subtle differences between them. So in IBGP, or an interior BGP, we have the same problem called non-transitive. We get into the same silly hub and spoke environment that I talked about before, where VPCB will tell A and A can't tell C, so they couldn't reach each other. So for those of you that are networking and understand BGP, you may recall that there's this thing that you can use to break the rule, and it's called the route reflector. And all a route reflector tells BGP is, hey, be transitive, by the way. And it would tell VPC B when it tells VPC A's routes to tell it to C. So we need some form of route reflector kind of technology on the cloud in order to do this, in order to do so. So this is where CloudHub comes in, and Transit Gateway. When you need to break the rules of non-transitive routing, you need a route reflector. Same solution we've used externally forever. And what happens is you've got multiple VPCs. You want to create a hub and spoke network. Hub and spoke networks are used everywhere. They're used in airlines. For me, for example, if I want to fly to New York and I live in Palm Beach, I fly to Atlanta and I go from Atlanta to New York. Hub and spoke. I want to go to California. I fly to Dallas and then I get to San Jose, or Houston and I get to San Jose. Hub and spoke networks. In networking, they exist forever. Connect to the New York office and that connects you to other places. Connect to the San Jose office and that connects you to other places. So what we're dealing with in the cloud is they decided to rename the route reflector and call it CloudHub. And CloudHub enables your systems that are connected via VPNs to have transitive routing on the cloud. Each site will use eBGP to connect to this little device in the center, and then our routing will work. So what's it going to look like? Here we go. We've got our cloud. We've got a Boston office, a New York office, our Washington office, and a San Francisco office. We all connect into the cloud. We use CloudHub over here, which means it can only support a VPN connection. Transit Gateway supports obviously direct connections and some other things. And now we've enabled our cloud to allow transit networking. So now Boston can talk to San Francisco through the cloud. Washington and Boston can talk to each other through the cloud. We've effectively created a transport network with VPN CloudHub. Now, the only problem with just VPN CloudHub is it only works with VPNs. And what happens when you need high performance networking, high performance computing? You don't want to use VPNs. So that's where AWS came up with the concept of Transit Gateway, which realistically speaking is the same thing. But Transit Gateway is the following. Now we can use private lines, for example, and connect to these systems. Still using eBGP, which doesn't have the non-transitive routing properties of iBGP. It's not forcing people to become familiar with route reflector technology. It's simple and elegant technology, and we've created a transit environment. So unlike CloudHub, with Transit Gateway, we can still use VPNs, we can use private lines and other network forms of transport, and that's why Transit Gateway is pretty much the way to go. Now, Chris, I'm going to get into access control lists and security groups. Before we do, did I have sufficient time, or do I need to stop here, take a few minutes, answer some questions, go to the next one? You're holding the time, Chris.
Yeah, we need to take some questions.
Okay, so let's take some questions. And if you haven't given us a like or subscribed or hit the bell yet, please do so. And while the questions are coming in, please give me a hashtag so I know you're awake. Hashtag AWS Certified Solution Architect Associate. TM, when they use the term programmatic access, are they always using interface endpoints? Programmatic access has nothing to do with endpoints whatsoever, TM. Programmatic access is when one system can talk to another system directly to each other. Typically, you would consider it to be a service account in Linux. Google would call it a service account, for example. And what it really is you got one computer that can talk to another computer, maybe an application server that talks to a database server, and you're doing it in a manner that enables communication between two people. That's what they're referring to when they talk about programmatic access. PrivateLink is established via PrivateLink, not AWS directly. It's its own service. VPC peering is not usually connected to a NAT gateway at all. VPC peering is connecting VPC to VPC. NAT gateway is when you would want to translate a private address to multiple private addresses to a public address connecting to the internet. So they're totally not related. Can you explain a bit more about VPC versus cloud and how you integrate it for the hybrid cloud? So, Lady Godiva, just think of a VPC as a mini private data center. So, if you have a Nutanix cloud, that you can consider that one VPC. If you create your whole business in a single VPC on the cloud, you could do so, and it will be your virtual private data center. But the problem, Lady Godiva, on the cloud is you have very limited control of access, very limited control in security, very limited control in filtering, very little micro segmentation. So what many companies is they take their global data center, when they move it to the cloud, they create like 100 or 500 mini data centers, and then they do VPC peering to allow the traffic they want and not the traffic they want in between them. But you could also use VPC peering for the following. You could use it to connect to external entities. So let's say I'm a car manufacturer. And as a car manufacturer, I need tires from 10 different companies. I need steel from different companies, aluminum from different companies, motor parts from different companies, rubber. I could use VPC peering to use the cloud as a means of networking to connect me to all these other partners. So I didn't have to build my own network like I normally would by building a network and requiring thousands of routers and switches to connect to these things. Marie George. Endpoint communication is simply a secure connection from your VPC to another resource. Well, that's one form of endpoint connection, Marie. The other form of endpoint connection could be you connecting to you. You connecting to you. Now, this stuff is the stuff that we're covering now is very basic, and we don't have as much time as we'd like, but we've got a whole networking boot camp where we're going to spend a whole week on these concepts, and we're going to get deep into the routing to make sure you guys all know it. Keep going, Chris. Wouldn't we become an ISP? No, we wouldn't become an internet service provider because we wouldn't be providing internet services. But we would be providing, if we used CloudHub, the ability to transmit through us, which we might want to do. Now, we might want our whole company to be able to talk to other parts of our company through VPC peering, especially if we've micro-segmented our network for security. So we might actually be building ourselves the private network the way we want it to be. We could also create an internet service provider if we chose to, but that would be with the process and procedures and routing would be very different for that. But yes, effectively become transit, but not an internet service provider. So, and again, there's a big difference between internet and intranet. Internet is the public internet, but most organizations have their own intranet and their own network. So if I segment my system down into 500 VPCs, and I want to connect my VPCs from my own private network, I'm not an ISP. I'm providing private network stuff, connectivity, or an intranet. What is NAT overlay? You transmit one IP address into many. So most of you guys and girls live in a house. You've got an internet service provider. You may have a computer, a mobile phone, a TV, and they all go to the internet using your single public address. That's called NAT overload, meaning one to many. But if I needed to reach any of your systems, I couldn't use NAT overload. I would need static NAT that maps Mike's address to Godson's address. So, there's different times where we need different kinds of NAT. But NAT overload is going to the internet. Sorry, I didn't get the transit gateway. The transit gateway and a CloudHub are the same way that you can connect your systems and create a hub and spoke environment. Now, transit gateway lets you do it with private lines as well as VPNs, and CloudHub only enables you to do it with just VPNs, which means IPsec traffic. That's kind of the same thing. Can I give an in-depth description via stateful, via stateless? Daniel, absolutely. We've done it on the first day, second day, and the third day, so in case you missed it or you just joined us, we'll do it again. Here is stateless. Let's pretend right now we're going to first start with a stateful firewall. My iPhone became a stateful firewall. Here I am sitting on my computer, and I type www.gocloudcareers.com. Me behind the firewall, I go to the firewall. My traffic goes through the firewall on the way to the internet, and then it hits the www.GoCloud server. The GoCloud Career service responds to it, and the traffic comes back to the firewall, and the firewall says, oh, the GoCloud Careers web server is trying to reach Mike Gibbs. Mike Gibbs initiated the connection. I'll allow it through. That's stateful. Stateless would be, I take my device, I would go through my firewall, and all firewalls are stateful, but let's just pretend they weren't for right now. I go through my firewall, and it's stateless, and I go to www.gocloudcareers.com. Now, if the firewall wasn't tracking what I did, www.gocloudcareers.com would answer, and the firewall would block it because it wouldn't know to allow the traffic in. Because firewalls block all incoming traffic except for what's allowed through it. But a stateful firewall tracks your traffic and allows you return traffic because it knows you initiated it. Good question to know. TM, it's a matter of using the right thing at the right time. Transit gateways need if you use more WAN options. CloudHub is if you use you don't. So that's the thing with architecture. There's never anything that's better. Never. There's never anything that's preferred either. It's what's the best thing to solve my business problem at the time. Now, I'd probably use Transit Gateway over CloudHub for the following reasons. You may think a VPN's good enough, and you may find out later that it's not. So I like to build myself more flexibility. But everything different has a different cost, a different plan, and you need to know how you're designing it and why you're designing it. I overbuild the network, and the reason I overbuild the network is I've got 25 years experience for people who thought that the network was an afterthought. And anybody that thinks the network is an afterthought, I promise you they crashed. I promise you people get fired. And I promise you they bring in somebody like me to go clean it up. Why? Because I've been doing it for 25 years. Mike, your way of teaching is amazing, smooth, and a question in the real world. Would a company use infrastructure as code to commission these VPCs? So yeah, and the reality, and that's a great question, and thank you so much. The reality is you're going to have a solution architect, a cloud architect, or an enterprise architect like me that's going to design it. And then it needs to be deployed. And we're not going to hire cloud admins to deploy it. It's just unfeasible and too expensive. What we're going to do is we're going to hire a DevOps engineer, and they're going to use Terraform, and they're going to deploy all this stuff via infrastructure as code. What exactly is transitive and non-transitive routing again? You know, I know why this question's coming up. It's honestly the ugliest thing. Truthfully, this took me a while to learn when I started networking. So let's just draw it out for you. I'm going to make it a little simpler. And we're going to use some of my friends, my favorite buddies, to actually help make this work. So the first thing we're going to do is we're going to take Sunny the cat, my chief operating officer's cat. It's a really nice cat. It's a cute cat. It's a Maine Coon. And I'm pretty sure I've got Abigail's cat. I hope she doesn't mind me using her cat, Noni. She's let me use Noni in the past. Noni is one of the cutest cats I've ever seen in my entire life. Let me see if I can find a photo of cat Noni. If I can't, I'll use another cat. But Abigail likes her cat typically getting some exposure out here. So if I can find Abigail's cat Noni, I will. If not, so let's, well, I don't think I can find one right now. So I'm going to use two different versions of two different cats here. We're going to use transitive versus non-transitive. Okay, on the left side of this cat, okay, we've got my cat Cindy, who is coming out from hiding under a bed. She thought it was really cute. And so there's this. And I know what we're going to use for the other cat. I know exactly how we'll use for the other friend in this example. We will use, I took this picture yesterday. It shows you a frame of perspective. My cat thought she was hiding. She wasn't doing a great job of hiding. But here we go. We'll take this picture. And we'll pretend this is another cat. My cat thought if I couldn't see her, at least this is what I assume she's thinking, nobody else could see her. So now we've got three cats over here. So now here's what transitive routing is. On the right side of this cat, let's call this Catty. Let's call this cat Sunny. And let's call this beautiful little cat over here my daughter, little Cindy. See how cute she is, everybody? Here's transitive routing. Cindy tells Sunny about the beautiful salmon that I cooked for her for dinner. And yes, I cooked for her for dinner. And then Sunny tells her friend Caddy, hey, when Mike's house, they're cooking salmon and seared ahi tuna. And then Cindy says, hey, Sunny, how do I get to Mike's house? And she shares the address. And then Caddy comes and visits Cindy over the house. So now we've got transitive routing. This is transitive routing because now Cindy, Caddy, and Sunny all know how to talk to each other and reach each other through Sunny the cat. Now here's non-transitive routing. Cindy tells Sunny about the beautiful salmon that her daddy Mike just cooked for her. Now Sunny's not allowed to tell Caddy about it. Now, Caddy tells Sunny that she found the cutest mouse, but Sunny's not allowed to tell Cindy about it. And because of this, now Cindy and Caddy don't know how to reach each other's cool stuff. That's the difference between transitive and non-transitive routing. I know I go to cats because they make me smile. Let's go to the next question. I know that I spent some time on that. CloudHub only allows IPsec. Only, but if you wanted to use Transit Gateway, that doesn't preclude you from other things. So it's only if you need IPsec. Want to know about veering versus account organizations for cross communication? Okay, here's the thing. VPC peering gives you real protection, meaning real protection network boundaries, which means network filtering and route filtering and BGP. Organizations is basically an identity and access management policy. So think of it this way, Godson. If in order to get to you, I had to cross a firewall and I had to cross your IDS IPS systems, a security group, a network access control list, and a security group, and now I'm knocking on your door, I'm going to use identity and access management. Who are you? What are you allowed to do? And keep track of it. Now, organizations only allow who are you and enable you to keep track of what was done effectively. VPC peering enables you to provide all the security and then all the IAM stuff. So they're not even comparable. Identity and access management is the last line of defense. So assume you had a castle, the king and queen and everybody that matters in the castle. The castle's got a giant wall, right? And behind the wall, there's a moat. And behind that, there's knights with these javelins and things like that. And swords. By the time somebody knocks at the door, they've already been taken out by the security. Now they're saying, hey, I'm Mike, let me in. Personally, I don't want to let them get to the door in the first place. I want to block them. So that's why organizations that use multiple VPCs, it's much, much, much more sophisticated than organizations. And you can combine those two as well. What are the rules for naming IP? I don't know what you mean by naming IP. What kind of device makes VPC peering between VPCs? It's the cloud. It's all virtual. So it's going to be virtual routers that you're going to use between them. If VPC peer hopping has overlapping addresses, you can't use it. It doesn't work. That's why you've got to use PrivateLink. Or else you would need to create some kind of a NAT long before you got to VPC peering. How do you overcome the limitations? You don't. You don't use VPC peering. You use PrivateLink, or you start getting into sophisticated systems like Aviatrix, which lets you create much better networks. See, when it comes to cloud networking, we're really about 20 years behind. And because of that, we have to do things in order to make sure what we're doing. Okay, so let's get into access control lists. So normally speaking, on a router, we'd create multiple subnets and we put an access control list between them. An access control list effectively says Cindy's subnet is allowed to talk to Caddy's subnet. That's what we're talking about. Now, reality is In here, we're going to do it via subnets. So network ACLs keep unwanted traffic out of a subnet. And network ACL allows or disallows traffic based upon a configured policy. The default policy by definition is to deny all traffic. So an access control list is going to have to specify the source and destination address, protocol, and port number. Access control lists are stateless, and because they're stateless and they don't have any knowledge of the state, they can be configured inbound and outbound. Inbound and outbound. So let's talk about how you put an access control list in order. You do the following. You create a rule. And I'm going to show you the way and reason the rules matter so much. Rule 100, deny all traffic. Rule 110, allow TCP port 80 traffic. What do you guys think is going to happen? Tell me in the chat box what's going to happen. Tell me right now what's going to happen. I can tell you right now. But tell me in the chat box what's going to happen. Rule 100, deny everything. Rule 110, allow TCP port 80. What's going to be denied, everybody? Tell me. It's going to deny everything. Why is it going to deny everything? It's going to deny everything because it already says deny. So it has to be done intelligently, correctly. We have to put it in sequence. So now let's change the sequence. First, we don't need to put any denies, and here's the reason to deny. It's implicit. The only time we do a deny, we would do a deny, and then a permit is maybe we have one bad host that we want to deny, and we want to permit the rest of the subnet. So yes, then we would do certain things, or we could just deny a single IP address. Now, what if I told you to just create a single rule? Rule 110, allow TCP port 80 from any source to any destination. What's going to be allowed in? Tell me what's going to be allowed in. Rule 110, allow TCP port 80. And while you type that, Effie, the problem before was, the reason the order matters, if we have a deny before an allow, and the deny is everything, everything would have been denied. Okay, Alex, we're going to allow web traffic into the web servers. Yes, Jeannie, port 80 web traffic is going to be in. Jason, port 80 web traffic is going to be in. Billy Manning, allow web traffic, so good. Now, because what you're dealing with is the ACLs are not stateful, meaning they have no way to track that you went out and to allow your traffic back. That's why you need to apply them in both directions. That's why. So now let's say we're going to do it together. Everybody give me Rule 110, allow TCP port 443. What's going to be allowed in? Specifically, what kind of web traffic is going to be allowed in? Basic unencrypted web traffic or only encrypted web traffic? Tell me in the chat box, everybody. Alexandros, Polikala, HTTPS, good job. Jason, HTTPS. Abji, HTTPS. Okay, perfect. Secure, HTTPS, web traffic. Okay, you got it. This guy's got it. It's encrypted. Now I'm feeling excited. I'm happy. So we have to put them in order. We have to apply them inbound and outbound because there's no state. Now let's see what it looks like, because this is going to be a test question, test question, and more test question. Here's what we're going to see. We're going to see our network access control lists are used to keep unwanted traffic out of a subnet. And then we're going to talk about a security group, which is to keep unwanted traffic out of a host. Access control list, unwanted traffic out of a subnet, network access control list, they like to call it. Security group keeps traffic outside of a host. Now, a security group, so while an ACL protects your subnets, your security groups protect your host. So let's talk about what that means. A security group as a stateful ACL. What's the stateful ACL called? A firewall, everybody. So a security group is similar to a host-based firewall. Does this mean you shouldn't put a host-based firewall on your server as well? Of course not. You're going to use both. Because when it comes to security and availability, 1 is none, 2 is 1, and 3 is greater than 2. But a security group keeps unwanted traffic out of a subnet. Out of a host. And a network access control list keeps security groups out of a subnet. Which you're going to use? Both of them. You can't just use one. You're going to need both and then some more. So all good system designs are going to include both, and more both. So keep that in the back of your mind. A security group being your host-based firewall. Now, when you write a security group, you don't need any denies. You just do allows. Why? Because you're only allowing stuff into a server, the minimum amount of stuff that you need to. If I want to allow FTP, I'm going to allow FTP. Not that we allow FTP anymore in today's world. If I wanted to allow TFTP, which we don't do anymore, we'd allow TFTP for the most part, which we don't do. If I wanted to allow secure FTP, I would just permit a rule to allow secure FTP, to allow HTTPS or HTTP. So we just create a security group, which tells. Now, when we create a security group, they're smarter than access control lists. All rules will be evaluated prior to denying traffic. So if we made the mistake of saying deny any, and then permit afterwards, well, at least all rules are going to be evaluated. So we're in a better shape. But only inbound rules are necessary. Why only inbound rules? Allow this stuff to come in. Because once it's come into us, we know where it's coming from. We're tracking the state of the connection. We allow the return traffic out. So let's going back to this diagram. What are we really talking about here? We're talking about the following. We've got our network access control list protecting the subnet and our security group protecting our hosts, our virtual machine, our instances, or any name that we choose to call it. Now, what if we wanted to create a network and use the cloud? So there's 2 ways you can create your own network. You can hire somebody like me and say, I need a network with 10,000 locations, and I'll design your beautiful wide area network. I'll determine the routers you need, the switches you need, your routing protocols, and I've been doing it for decades. And when I design a network, it's going to work, it's going to be high performance, but it's going to cost you money. Because if you've got 30,000 locations, realistically speaking, you need 60,000 routers. These routers could be $30,000, $40,000 each. Each router is then going to need its interfaces, might need a WAN connection. Each WAN connection, say it's $1,000 a month. Then I'm going to need 3 CCIEs at $300,000 a year to be able to maintain this thing, at least to design it, high-level stuff. I'm going to need a network operations center. I'm going to need some basic network engineers that can keep stuff and running and build the stuff that we architects do. And it's going to get real expensive real fast. Or if we're connected to the cloud, we could actually use the cloud to build our entire wide area network. What that's called is a transit VPC. It's another way to create a hub and spoke environment through the cloud. So a transit VPC, it pretty much is an intermediary that allows you to connect multiple VPCs, multiple customers, multiple organizations through something. What about a service provider? Let's not go that path for this class. It's essentially a way to use the cloud as a private network. Now remember, you could create multiple VPNs on the internet. You could do it. Each VPN is going to need a router and a connection to the internet. But here's the thing. Internet bandwidth is not guaranteed because it traverses multiple internet service providers to get to your destination. But you can guarantee the performance on your network. AWS can guarantee the performance on their systems. So we can create this transit VPC. We can basically connect to anybody who's connected to the cloud already And we can use the cloud as a conduit, as if it's a router. So a transit VPC acts like a cloud router and directs all traffic, in a much the similar way of VPC peering and CloudHub. When we use a transit VPC, it has hubs and spokes. And we use BGP as the routing protocol to exchange information. The data is never going to be routed through the public internet, but use the AWS private high-performance network. It's an elegant thing. The transit VPC has all spokes directly using it, and it's going to be using our exterior gateway routing protocol, otherwise known as BGP. Data keeps flowing, and it's privately and it's automatically encrypted across the private network. So private network with encryption, high performance, high security, elegant. Very elegant. Okay, let's talk about implementing network performance and placement groups and what they are. So let's say you had a low latency application. I'm going to tell you right now, most of your critically low latency applications, you probably shouldn't put them in the cloud. You should keep them in your data center. By putting them on the cloud, you've got the latency of your wide area network connection, multiple network hops, slower storage, and all the challenges that come from a virtualized environment. But if you wanted to, how do you achieve the best performance in the cloud? And this is where we get into placement groups. Now, placement groups are logical groupings of your servers inside of a single availability zone. Instances in the placement group are close to each other or proximate to each other. And by putting your stuff close to each other, what you really get is lower latency and high performance. Kind of keep that in the back of your mind. And so we're going to talk about the kinds of placement groups you can actually deal with. So the first kind is a clustered placement group. Clustered placement group is the way you get your best performance at your lowest latency. Now, in architecture, everything is a trade-off. Everything is a trade-off. So if we put our stuff close together, the latency to connect to our devices is nothing, right? Yes. But let's talk about what can go wrong. Generally, placement groups are where your servers are all in the same physical server. And you're not traversing the network at all, just the backplane of the server. So you've got very low latency and the incredible performance. But you've got very, very little redundancy. So let's talk about what we're dealing with. If you put all your servers in the same rack, and they're connected to the same network port, to the same power distribution unit, hopefully 2 power distribution units, and there's a power failure in the rack, your whole placement group is gone. Can't have that. The circuit breaker blows. Can't have that. Now, what if all your stuff is in the same server, and the server encounters a hardware failure? Whoa, okay, now you're still down. What if the switch that's connected to the server fails? You're still down. So cluster placement group, critical performance. Look, I've worked for banks when they needed critical low latency. And here's what we did. We had 2 racks side by side, each plugged into different outlets, two different power supplies, 2 different power distribution units, multiple switches plugged into the back of these things. And that way, if one died, we'd fail over to the other one kind of instantly. We couldn't even use regular routing to get through the routing. We had to come up with specialized routing to tune this to get maximum failover performance. So clustered placement group, lowest latency, highest performance, single point of failure, scary. If you're going to create one, create a second one. So let's talk about a way that's going to give us good performance but not necessarily optimal performance. This is going to be a partition placement group. And in a partition placement group, our instances are grouped across racks. This protects against failure of a rack power, network switch. And because we're providing systems across racks, we've got a little more latency, not much, but excellent performance with much lower risks. So what are we really talking about with regards to latency? The speed of light, which is 186,000 miles per second. Now, when we go 1,000 kilometers or more to the cloud, that has latency. But if we go 20 feet in the data center, is that latency worth talking about? It's not. So a partition placement group is, inside of the same data center spread across racks. Excellent performance. Not quite as good as a cluster placement group, but, we're getting into some serious stuff here. Good performance, high quality networking. Rack 1, Rack 2, Rack 3, all in the same building, same data center. So good performance, we don't lose money. Now, let's say we want a little more availability. What if the data center fails? It could happen, right? Data centers fail. So now let's talk about a spread placement group, okay? So here's what a spread placement group is. AWS has these regions, these large geographic areas, and they've got a bunch of data centers in the same region. And a lot of their data centers could be across the street from each other or close to each other. So a spread placement group is when you put your stuff and spread it across availability zones in the same region. So by doing so, what could we do for you here? We can put 2 in building 1, 2 in building 2. We've got a fiber optic connection between them. So the latency is still relatively low latency. We've got a much higher availability system. Now, believe me, this is higher latency than a clustered group, but it's got much more availability. So when it comes to architecture, there's never, ever, ever, ever a single thing that we can do. The key is as follows. What do we need for this application? What's the need that we're going to do? I don't know if I shared my screen with the clustered spread placement group. It's going to look like this. Now I understand what we're actually dealing with the spread placement group. Now let's talk about some kind of network performance and training. I'm going to use some complicated terms that I hate it. I hate marketing fluff. So if you've ever worked in a virtual machine environment in a data center, and let's say you were dealing with a VMware server and you needed really good performance, like GPU performance. Well, a virtual GPU's performance is terrible, but a physical GPU performance is great. And if you've ever built a virtual machine that was designed for machine learning, you might take your virtual machine, and you might push 4 Quadro 8000 cards into a single virtual machine. And that's called PCI pass-through. And what that does is enable you to put a physical card directly into your virtual server. And we've been using this for machine learning for a while. People that would create lots of devices that needed high performance. Now, the problem is when we deal with a network card in a virtual environment, it's not the physical Ethernet card that's in the system. It's a virtual card that's created in software. I want you to think about this. Hardware fast, software slow. So for people that were mining Bitcoin on their GPU, they might be able to do a few thousand hashes per second. But if they bought an ASICs or hardware, they could do trillions of calculations per second. Thousands versus trillions. Hardware is fast, fast, fast. Software is slow, slow, slow. So if we needed high-performance networking, the first thing we could do is push a physical network card directly into our server. So you'd think they'd call it physical network card. But no. Marketing people get paid a lot of money to come up with crazy names to make it sound cool. So the first network performance option we have is something that's called Single Root I/O Virtualization, SR-IOV. Here's what it means. Pop a physical card and pop the physical card in and push the physical card in the virtual machine. And there's that. Now, the next thing that we're actually going to talk about is as follows: the virtual fabric adapter. For organizations that need real high performance, the other alternative with AWS is they've created a specialty software driver. And the software driver can offer some incredible performance. And the performance can go up to 400 gigabit per second. It's not there yet, but the driver is designed to support this. So what we're dealing with here is very, very cool stuff, network performance options, and there we're going to go. And I see there's something about a puppy in the chat box. I've always wanted a puppy in my entire life, but my wife would only support cats, and I'm allergic to everything, so I have a cat named Cindy. Now, we're going to get into DNS next, Chris, and DNS is going to be a topic that I'm going to need to spend 30 to 45 minutes on. So how long has it been since my last question and answer session?
It's been about 20 minutes.
Okay, perfect. Let's do 10 minutes of question.
And in response to Dennis, I did bring a dog home once. It was gone 3 days later.
Oh. I've wanted one my whole life. Especially golden retrievers and yellow labs. They're my two favorite, but I like all animals. So we'll wait for some questions. While we wait for some questions, I'm sure there's probably been some questions I can do before. If you can give me, so I know you're awake, a hashtag AWS Certified Solution Architect Associate. And I hope that doesn't get in the way with what Chris is trying to do, pulling questions up.
You know it does.
Oops. Can I explain VPC transit approach? 100%. VPC transit is, I create a special environment that enables organizations to transit through my environment. So let's draw it out one more time because I love dealing with this kind of stuff. So let's deal with this. A transit VPC or anything like this is I create a little environment. We'll call it transit VPC. And over here, what we'll deal with, a transit VPC in one case. We've got a, so let's call this Cindy's VPC. Call this Sunny's VPC. Inside, Cindy's VPC, she's got all kinds of incredible stuff going on in there, and her favorite things are going on inside of her VPC. And inside of Sunny's VPC, there's doing some other stuff. So, the cats are happy, they're doing their thing. Now, if Cindy, by comparison, wants to talk to Sunny, there's two options. In the real world, we put a little router between Cindy, and a router would be a circle, not a square, but hard to. And we'd get an Ethernet over MPLS, create a VPN, a private line, and all these other kind of things. That's normally what we do. Now, what would happen is we'd have to buy this link from AT&T. We'd have to buy this router from Cisco, and it's automatically beautiful. But now let's just say Cindy is connected to AWS, and that means that Cindy, here's AWS's network. We're going to draw it as if it's separate networks, even though it's not. Cindy's got her direct connection to AWS. Now Cindy's got this beautiful friend who's a Maine Coon, and this beautiful Maine Coon he likes to send messages to in the middle of the night, and those Maine Coons say are connected via this. And then so what we do is they're both connected to the internet, to the AWS network. Now, by comparison, we create this transit VPC, and now Cindy and Sunny can talk to each other over the AWS network without buying routers, without buying private lines from internet service providers. That's what we're talking about with the transit VPC. It's a means for two organizations to talk to each other. So I hope I answered your question there. Chris, bring in the next question. If we want to create an endpoint to an S3 bucket, do I need to create a bucket policy and the policy at the endpoint? You create a bucket policy to determine what your user privileges are for the bucket. You create the endpoint so you can reach the bucket. What they do if your VPN connection keeps dropping out, get a new internet connection. And here's the thing. You should never, ever have only one connection. You should have minimum of 2 connections. And they can't be on the same internet service provider. That's why you can't use a single cloud. It's a single point of failure. So in my house, for example, just to stream to you today, I've got an AT&T fiber optic link, a Verizon fiber optic link, and then an AT&T 5G access system. And that way, AT&T goes down, I use Verizon. Now, of course, it'll take my router and BGP about 30 seconds to transition systems, but I always have more than one internet connection. No business can ever run on a single internet connection. Now, normally speaking, you might need 2 internet connections, 3 internet connections, and if it really matters, you can have a direct connection, multiple direct connections, or direct connections with multiple VPN backups. Great question, Shameless. Chris, we'll go to the next one. Collins, how do we secure data in use? Now, Collins, I know you, and I know how incredibly smart you are, and amazing in many ways, but I don't actually understand your question. And what I mean this is what we're dealing with is, I don't know if you're talking about encrypting data over the network, in which case you could have a private line, which is private, and still run IPsec on top of it. You could also be securing data in storage by encrypting your storage volumes. We could have an IPsec connection, and we could also still be running SSL traffic between our servers, so we can be encrypting via SSL and IPsec at the same time. I'm not sure if you're talking about data loss prevention strategies, which is not my area of expertise, but there's a lot of ways that question could be actually answered, and that could literally be take 2 weeks to answer that question if I knew exactly which one. So, Collins, bring that question to class. And normally we talk about it, but let's get deep into that question, because that question is going to be something that's a little more significant than we can address in a single boot camp.
That's it for now.
Well, we can address Mahesh's question real quick. And why is there IPsec over an interconnect direct connection in a hybrid cloud? Well, there usually isn't, but you might want to. So here's the thing. In a real world, a private line is a wire just between you and your company. In the real world. In the cloud, if you remember from our direct connections, we buy a WAN link to us, and then the service provider connects us to the AWS router or switch, and then they stick us on a VLAN and backhaul us across their network. So it's not exactly a private line. Now, what we might also choose to do is encrypt the private line, and here's why. I want you to think about security in the following manner. Let's take you have an onion. You peel off the skin of the onion, you got a first layer of the onion. As soon as that gets breached, you remove that, you got another layer of security. You get hacked past that, you get another layer of security. You hack past that, there's another layer of security. So security is like dressing for cold weather, layer after layer after layer. You must assume many layers are going to be breached, and that's why you package it that way. It's a good question. Can I re-explain the placement groups? Sure, I can do that. Cluster placement group. Every single server in the same rack. By being close, 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 you got speed, 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 speed. But by being close, close, close in the same rack, something happens in that rack, you got nothing. 2, what's the next thing that you need to do? A spread placement group. What's that? Put your stuff in multiple racks in the same data center. Now you've got availability. But what problem do you have? It's slightly slower, but it's still fast. And partition placement group is put your stuff across multiple data centers. Slower speed, but much more availability and redundancy. Good question. Godson, does VPC peering work with AWS private network or internet? It works in the private network, and it could also be done over the public internet with regards to VPN. I'm going to address Robert's, even though I said no career stuff. Robert, the reason we say don't do the AWS Advanced Security is it's so weak and too junior that it's not valuable for anything. It's not even an intro to an intro to an intro to an intro to junior level security, and no manager will take it seriously. They will take a CISSP, a CEH Master, an Offensive Security Pro, but that's why we say don't waste your time on the security specialty exams like the security cert. It's just too basic for anything. If you have 2 VPCs with overlapping IP addresses and they have a direct link, well, you can have 2 companies with overlapping IP addresses with a line between them. But what you have to do is you have to use NAT between them until you can re-IP address your systems.
All right, and this next one is the last one.
Okay.
Unless we already did it, I can't remember.
We did it. VPC peering can work with, you could set it up over VPN access, or it could be done over the AWS cloud. Good question. All right, now give me a hashtag AWS Certified Solution Architect Associate so I know you're awake, alert, and oriented. Remember, I'm a medical person. In medicine, somebody falls over, we say, hey, what's your name? Who's the president? What's going on today? Where are you? Because we want to know that you're oriented towards person, place, and time. So give me a hashtag AWS Certified Solution Architect Associate. And then we'll get back to the content as long as I know that you're there. It's hard to do this. I've had laryngitis now for 2 weeks, and I want to make sure that we're doing it and you guys are paying attention. So I want all of you to have the best possible careers. Fantastic, fantastic. I know you guys are here. Now let's talk about DNS and Route 53. What is DNS, everybody? DNS is simply a way to map a name to an IP address. So let's say you wanted to connect to an IP address. You could do it any day of the week. You can put the IP address in your browser and it's just going to work. No big deal. Now the question is, can you remember everybody's IP address? My wife, yeah, she can remember everybody's IP address. Here's what is the phone number. Lisa, the phone number is 256-345-78910. And I asked Lisa, what's the phone number? And she'll tell me a year later, 10 years later, 30 years later. Now me, I don't remember what time I'm supposed to be somewhere sometimes. I'm exaggerating the concept. But, you know, for me, it's very easy to remember Cindy the cat. That would be easier than to remember her DNA sequence. That would be harder to remember. So since every device needs to be reachable, that you want to be reachable needs an address, you could either be a genius like my wife with 170 IQ and remember everything, like an elephant, or you need some sort of mapping agent. And this is where DNS comes into play. It's very easy for me to remember Amazon.com. But out of curiosity, let me do an NS lookup and actually find the IP address of Amazon.com. The IP address of Amazon.com is 162.219.225.118. Now, which do you think is easier to remember? Amazon.com or 162.219.225.118? Well, I'm going to tell you right now, I can remember Amazon.com, and I already forgot the 162 after the 219. Now remember it a week later, and now we got challenges. So DNS is really a means to map a name to an IP address. Here I go, I'm sitting on my browser, I type www.amazon.com. Now my computer goes to the DNS server, the DNS server returns the IP address, and my browser redirects me. Now here, I'm going to actually do an example with you. Every one of you, all of you, I want you to open up a window. On Windows, it's going to be your command prompt. If you're on a Mac or on a Linux system, open up a terminal. Do the following with me. Let's go find the IP address for gocloudcareers.net. So every one of you type NSLOOKUP, November, Sierra, Lima, Oscar, Kilo, Uniform, Papa. Leave a space. And then after you leave a space, type www.gocloudcareers.com, just like I did in this example that I'm sharing with you right now, or at least I meant to be sharing with you right now. And here you go. What IP address did you get on your computer? You did an NS lookup. Pop the address that you got in the chat box. Now that IP address may be different than it was when I ran this, but here's what you're going to do. You're going to do an NS lookup, and you're going to be able to find the IP address to any website. After we do mine, do an NS lookup to www.cisco.com. Big website. And that's what DNS is doing. It's mapping a name that we can remember, like gocloudcareers.com, and we're mapping it to the IP address of 192.0.78.217. There you go. Now I can remember gocloudcareers.com, but 192.0.78.217, that's a little harder for me to remember, even if it's my own IP address. So that's why we came up with these things. But DNS can also do some more. But let's go what talks about what goes into a DNS name or a domain name. A domain name is going to be broken down into three sections. Now, when we talk about a fully qualified domain name, we're talking about the following: the host name, which is the given name of the endpoint, the domain name, and the top level domain. So if we go to www.gocloudcareers.com, the host name is going to be www. The domain name is going to be gocloudcareers. And the top level domain is going to be .com. Could be .net, which I also own. But those are the kind of things that it could be. So fully qualified domain name. Host name, MikeEC2.gocloudcareers.com is a fully qualified domain name. Now, we work with DNS, you got to be dealing with something called DNS records. DNS is kind of like a database that maps IP addresses to different addresses, so we need to have these things. So when we're dealing with DNS records, we're dealing with something called the zone file as well. Same thing, DNS record, zone file, I don't care what you want to call them. And what they are they're sets of particular instructions that are located in the DNS servers and provide information about the domain. The records are in a particular format known as DNS syntax, which is a type of text file. And the DNS syntax is instructions to tell the DNS server how to carry out its action. Now, when we're dealing with anything on the internet, we have something called the TTL, or a time to live. And the TTL with DNS is how many seconds it will take for the DNS servers to refresh its information. So why do we need a TTL? If I put an IP address and it was permitted in the DNS, and then we changed IP addresses, nobody would ever figure it out. So we can't leave records up there forever. Now, there's a tremendous number of DNS records that you're going to need to know, and we're going to talk about them. So kind of keep that in the back of your mind. Understand when we talk about DNS and AWS, we're going to be talking about Route 53, which is AWS's highly available, scalable DNS platform, which uses something called NACast. It's low latency, high availability, supports health checks. But here's the thing to remember. If you want a high availability cloud architecture, a true high availability cloud architecture, you're not going to use AWS Route 53. And here's what. AWS Route 53 is the AWS proprietary DNS system. So now imagine you use Route 53, which is great DNS, by the way. And now you've got the Azure cloud, the Google cloud, and your Nutanix cloud, and the AWS cloud. And now you're using all your DNS from AWS. And AWS goes down. Guess what? None of your other clouds are going to work either. So when you're dealing with high performance, high availability systems, you can't afford to use your cloud provider's DNS. You're going to need to use a critical high availability system, the kind of thing that we've always used from F5 or any other way you want to do it. And we're going to put DNS servers in each cloud and data center. Now, you don't need to know every DNS record, but there are certain DNS records that you, for the most part, need to know. You need to know the A record, which will cover, the AAA record, which will cover, the C name record. You definitely need to know some of these start of authority records and MX records and the C name record. We'll probably I'll cover a few more of them, but kind of keep this in the back of your mind. They are critical knowledge. So let's start with the most fundamental record, the simplest thing. The A record, it maps a name to an IP address. 1.2.3.4 to prettycindythecat.com. One day I'm going to make a website, prettycindythecat.com, if I ever have more than 5 minutes to myself. And if I have 5 minutes, I usually spend it with my cat Cindy or my wife. And it just maps a name to an IP address. Now that's with IPv4. A record, one address maps to the IP address of the website. Simple and thing. Now, what if I had an IPv6 address? Well, then it wouldn't be an A record anymore. It would be an AAA record. AAA record. So an A record and an AAA record are identical. The difference is an A record is used for IPv4, an AAA record is used for IPv6. Now, next on the list, we have a C name record. Oh, why do we use a C name record? Well, I'm going to show you why we use a C name record in a second. So, okay, so let me make this a little bigger. Chris, I'm going to need your help figuring out how to share a window on my screen. Let me go deal with this. Bear with me. Let me present a window. Share a screen. Window. Okay, can you guys, okay, good. You guys can see my screen. So I did an NS lookup about Amazon. And if you notice, what you're really going to see is first, these are my Google DNS servers. Why does it have a hashtag 53? Well, 53 is the ports, the DNS, the TCP UDP ports that are used by DNS, and that's why it's Route 53. That's why it's 53. AWS calls it Route 53. And you're also going to see that Amazon.com, this is actually its DNS name. Now, this is what's pointing to it. Now, what is this ugly thing? This Delta 3 Alpha Golf 4 Hotel Uniform Kilo Hotel 62 Yankee November.cloudfront.net. That's actually the address of the content delivery network that's used by Amazon.com. Now, if you think any of you are ever going to remember that, except for my wife or those of you with photographic memories, you're not. But you can remember Amazon.com. So a C name record will map Amazon.com to this ugly, clunky name, which is the actual name. So it's effectively like it's mapping one IP address to another IP address. And that's why we're creating a C name record, to map one IP address to another IP address. I'm going to stop sharing right now if I can figure out how to do that. Share screen. And Chris, you can stop sharing that. Okay, so there we go. So that's why we're creating a C name record. It's not exactly an alias record, but it's kind of mapping a domain to another domain. Now let's talk about an NS record, or a name server record. Well, we've got DNS servers, but we need to know what are the real DNS servers. The most authoritative servers, the servers to trust. The servers that propagate our organization's DNS information to the rest of the internet. We need an NS record that identifies those servers. Now let's say you want to receive email. So my cat Cindy, she's cleaning her fur, doing cute little hand stuff, and she wants to send an email to her friend Sonny the cat. Well, if you or your organization wants to receive email, you need a mail record called an MX record. So an MX record, what we're dealing with, is really a record which tells you which mail servers can accept and receive mail from your domain. Last record we're going to talk about is something called the Start of Authority record, or SOA record. And that's the primary name server responsible for your domain. It tells you the responsible party for your name. And it'll have a timestamp that lists any changes that were made in a number of seconds before your information should be frozen. So now let's talk about Amazon Route 53. Route 53 is a highly scalable proprietary DNS service provided by AWS. If you use AWS and AWS alone, it gives you a very nice low-cost method for DNS. It supports IPv4, but IPv6, but remember, it's proprietary. And if you use multiple clouds and AWS goes down, you lose all your clouds. So you don't want to be using something like this in a high availability environment. You want a high availability DNS solution. But for your exams, here you go. Now there's nothing wrong with the service. It's a great DNS service. The problem is when you put all your eggs in one basket and the basket gets dropped, all your eggs are lost. That's why people diversify their portfolios and don't have a portfolio of a single stock. That's why organizations never use the same service provider. When they have a WAN, they use two different service providers. That's why it's insanity to use a single cloud when you should be using multiple clouds. Same problem. Now with Route 53, you can route customers inside or outside of AWS resources because it's standard DNS. And you could use Route 53 to connect to AWS and Azure and Google. The problem is if Route 53 goes down, you lose your other clouds. You don't really want to do that. The way DNS servers always determine whether your endpoints are healthy with a health check. So they work via health checks. I'll be describing health checks in a minute. I may actually give you a health check right now. So Chris, are you on the other end of this phone right now? I'm going to do a health check. Here's what a health check is. Let's say, Chris, is there anybody else behind the scenes like you right now?
No.
Okay, so it's just Chris. Chris, are you there?
Yes.
Chris, are you there?
Yes.
Chris, are you there? Ooh, Chris just failed his first health check. Chris, are you there?
Yes.
Oh, good. Chris is here. Now, I can keep sending traffic to Chris. But let's pretend I had two people there. Now, there's going to be Chris 1 and there's going to be Chris 2. Chris 1, are you there?
Yes.
Chris 2, are you there? That's scary. Chris 1, are you there?
Oh, sorry. That was me. I'm over here coming up with accents and I'm muted. Yes. Chris 1 is here.
Chris 2, are you there?
Yeah, man. We jamming.
Okay, good. And Chris knows I love Bob Marley and anything Jamaican. Chris, are you there? 1, are you there?
Yes.
Chris 2, are you there?
Yeah, man.
Okay, see, I'm happily sending traffic. Now, Chris 1's going to get really tired and lazy and not be there. Chris 1, are you there? Uh-oh. Chris 2, are you there?
Yeah, I don't know what happened to the other man.
Okay, Chris 1, are you there? No, he's not here. Chris 2, are you there? Chris 2's there. Otherwise, we're in real trouble.
Yes.
Chris 1, are you there?
Yes.
Okay, now the Chris 1 just passed the health check. Okay, I was hoping Chris 1 was not going to be there so we could revert all traffic to health 2. What the health check is your system is asking somebody if they're there. If they don't respond, you send your traffic to the other device. But it doesn't always work, and it completely clumsy, uncoordinated, no matter where you try to do it live. So there you go. And that reminds me, I need more turmeric tea for my for my laryngitis. I did have some Bambi this morning with breakfast, but I need some turmeric tea. So now if we're going to use DNS to determine what's available and map a name to an IP address, can we use it for more? And the answer is, of course we can. We can use it for high availability. So let's deal with high availability. We're first going to begin with a simple routing policy. And a simple routing policy is the most basic form of routing. And what are we talking about here? You have one DNS record and it maps to a single IP address. So Cindy the cat maps to 1.2.3.4. Simple routing. Very, very simple. Now, that's great if you've only got one website. But what if you have something different? Let's say you want to send traffic to two places. Let's say you want to spend 50% or 75% to your data center, and you want to produce 25% to the cloud. Well, you could use a weighted routing policy. Weighted routing is really cool. You send 50% to Azure, 50% to AWS. AWS goes away, send 100% to Azure. That's weighted routing or weighted routing. Weighted routing is also good when you've got new applications. So let's say you want to test a new application or a new website in this particular environment. We could send 85% of the traffic to the website that's existed for a long time and 15% to the new website. And that way, we could test it with a subset of our customers before rolling out a brand new website to the entire world. What if the website crashes? So when you see blue-green deployments and things like this, they typically use, for new applications and new code, they typically use some form of a weighted routing policy. Latency-based routing. Latency-based routing enables you to direct your traffic to the site or the region with the least traffic. Now, how does this work? Well, it really works based upon your IP address. See, I go to the internet, and it determines via my IP address that I'm in South Florida. It will send me to their web server in South Florida. Now, what if I was in Tokyo instead of South Florida? Would I want to go to the Florida website? Probably not. I might want to go to the web server in Tokyo or Kyoto or someplace else that would be close. By comparison, that's what latency-based routing does. It determines where you're at and determines what's the lowest latency server next to you and sends you to that server. That's pretty cool. Latency-based routing. I'd like to look at it this way. You hit our site. Which one's got the lowest latency? Send it to the site with the lowest latency. We're not Go Cloud Architects anymore. We're Go Cloud Careers, but there you go. Maybe slides a long time ago. Now let's talk about failover routing. I love failover routing. Failover routing is done by the following. It enables you to create your active and passive systems. So send all traffic to AWS. AWS has a cloud outage, send all traffic to Google. That's failover routing. And that works via the health checks that we didn't demonstrate as elegantly, but I'll be demonstrating a health check very soon. The point of failover, it's going to check the health. And if one goes away, there's good. So let's look at it in this environment. Here we go. We've got our main servers. Go Cloud Architects primarily goes to the primary one. But if it fails, it goes to the secondary one. That's called failover routing. I absolutely love it. Geolocation routing. Now, this is really, really cool. Geolocation routing policies looks at your user and puts them to the website that's closest to the user. But we can get pretty cool with this. Let's say you're in a country like Cameroon. I have so many wonderful people with us from Cameroon. Now, there's an English side of Cameroon, and there's a French side of Cameroon. And if you want something in English, It's pretty easy to do. So we could set up a routing policy that could say French side in Cameroon goes to the French web page. English side goes to the English side based upon your source IP address. So that's actually called geolocation router, and it sends you the source that's closest to you. But think about countries where you speak, there's 3 languages in these countries. Many countries, there's 2 different languages. Many regions, there's 2 different regions. Greece, where I'm from, is pretty close to Egypt, which is pretty close to Israel, which is pretty close to Turkey. Well, in Turkey, they speak Turkish. In Egypt, they speak Arabic. In Israel, they speak, Arabic, as well as Hebrew, as well as English. And in Greece, they speak Greek. Figuring out my IP address and sending me to the right website is the determination whether I buy something off of that website or whether I read it and go, I don't know, it's not Greek. And I don't know how to read it. So, I kind of love these kind of things, but we use it like this. I love geolocation routing. Where do you go? Go to the place that makes more sense to you. No, multi-answer routing policy to me is ridiculous. It's the biggest random thing in the world. I don't do random. I don't do random at all, but geoproximity, multi-value answer is you've got multiple entries, and it's just going to randomly pick something to choose from. Kind of like rolling the dice, and I don't like rolling the dice with any architecture. Here, throw the dice in the air, and where are you going to go? Which one of these websites you're going to? But it still uses a health check. So we'll only send your traffic to a healthy system. Now let's talk about geoproximity routing. This gets a little ridiculous here. This lets you divide your region into different parts of the world. And AWS then lets you kind of do the following. It enables you to create something called a bias, which is going to spread and shrink regions. And by changing your regions, you can shift where your traffic's going to focus. Keep that in the back of mind. I've never used it for anything. Then again, I'm always going to use my own DNS. In a tiny business, you can use the DNS from your provider. In a big business, you've got to manage your own DNS servers. And if they need a cloud architect, they're going to be managing their own servers. So let's get back into this concept of the health check, which I tried to demonstrate before. It didn't exactly work, but my team didn't coordinate it ahead of time.
I'm a quick learner.
That's okay. The health check's going to monitor the functionality of our stuff. Anything's have fun when you go live. If the system doesn't respond to the health check, it'll be marked as unhealthy. Now, I wasn't sure if the slide was here because we got our slides beautifully redone, and I was trying to create some availability, but it is, so let's do it. Here I've got 2 responses. Hey, server 1, are you there? Yeah, it responds, yeah. Server 2, are you there? No response. That's getting scary. Server 1, are you there? Sure am. Server 2, are you there? No response. Server 1, are you there? Woohoo! I'm here. Server 2, no response. Shift all traffic to server 1. So Chris, the next topic is load balancers, which is one of my coolest, favorite, most happy things to talk about in the entire world because I love them. They improve performance and availability. Is it time for questions or do load balancers?
It's time to give a chance for questions.
Okay. Isn't DNS provided by your service provider? So if you have multiple service providers, you have multiple DNS? No. Now, if you're basically getting web hosting from a small service like WordPress, which is a good hosting service for people's blogs and things, then yeah, it's managed by them. If you're just getting your stuff managed by, mom and pop website, it's managed by your service provider. But if you're an architect and somebody's hiring you as an architect, you're going to have to manage your own DNS servers and your name servers. And you'll have a single DNS across clouds. Good question, though. Apologies, I thought you had sent a question regarding CloudHub versus Transit Gateway versus CloudHub. You understand the difference between the two, but between Transit Gateway and Transit Hub, it's really all the same thing. What they're really talking about with some of these things is the ability to create pseudo connections across the wire. So let me just put it into an example. I'll draw it again. Where all this stuff is really the same thing, but I'll share my screen and draw it. So Transit Gateway is really designed for that transit VPC peering stuff. And you've got one over here. You've got one over here. Got a VPC over here. So let's just call them 1, 2, 3. You got the central kind of thing. So this is really designed to create a hub and spoke environment. There's another transit thing that we were actually asking about. Drawing a blank on the name because I can't use any of these names with my customers anyway. If I use any of these names in front of a customer as a real cloud architect, they'll be escorted out of the room. My replacement will thank me for the real job. Because when I use terms like elastic, it would make my customer think that I'm not objective. I'm not a real architect, and I've just been trained to sell somebody stuff, and that does not work. So there is that. And what the other question you're asking about, and I don't really remember the name of the service, is more of the pseudo connection, pseudo wire stuff, which is basically you connect to the cloud network, and here we'll get rid of the fill on the cloud network. Get rid of the fill. No fill. So here we've got it. We want to connect to other stuff. And this is really, realistically speaking, I know what you're referring to. I can't think of the name right now. Where basically you connect to the cloud and they're all connected to the cloud. And regardless of any of these names that they call, there's lots of services like this. Public VIFs, private VIFs. What they enable you to do is to connect a virtual wire over the cloud. So now one can reach 2 over its direct connection. And heck, if you wanted 1 to reach 3, you'd create another virtual wire over here. And then if you wanted 1 to reach 4, you'd create another virtual wire. The first time I worked with this kind of cloud technology was back in 1996. It was called Frame Relay. Then the next iteration of this, which was a little faster, was actually called ATM. I worked with that in 1998. Then around 2000, I worked on the BGP VPN, which was very similar to this. In 2001, we created something called Virtual Private LAN Services, which again was basically the same thing with the new name. And now we're bridging Ethernet over an IP network, but it's pretty much all the same thing. All the stuff that we're talking about today, all of it's 20 to 30-year-old technology. Does DNS vary region to region? I don't know what you mean by that. It's going to be the same DNS servers that are made by the same people that you use per region. Can I talk about DNSSEC? Mauricio, it's not my biggest area of expertise, but I will tell you what it really is. What DNSSEC is, let's say this is the DNS server. And realistically speaking, if you wanted high security environments until last year, you couldn't do it on AWS Cloud because of this, because they didn't support DNS. So what DNSSEC does is, this is the authoritative server, the real one, right? Without DNSSEC, we can have some intermediary pretend to be the DNS server. So by having a pretend DNS server, we could be given the wrong information to the wrong website. So it's more of a means to protect, to make sure that you actually know which web servers you're actually talking about and that they're the authoritative sources. But I'm not a DNSSEC expert, because DNS is typically done by the sysadmin people, and I'm a network person by nature, or an enterprise architect by nature, enterprise cloud, where we're doing the end-to-end picture. But I know a lot of DNS experts, I can tell you that right now. Is there similarity between a DNS service and a content delivery network service? Not at all. So they're totally unrelated. Shameless, I know where you're from. Kind of like comparing Injera to Durwat. Two of my favorite things in the entire world, by the way, but they're totally unrelated. And by the way, it's my favorite, two of my favorite foods in the entire world, which is why they always come to mind. Does AWS repeat questions? I don't know what you mean by that. On the exam, could you see the same question twice? It all depends on how the randomizer gives you the questions. But you may get asked the same question in 4 different ways. That'll happen. Okay, let's get back to the content, everyone. Now let's talk load balancers. I love load balancers. I think they're the coolest thing ever. We network architects don't work with them, but you know, they're cool. And why do I love load balancers so much? Well, load balancers are devices, and yes, I called it devices, that enables you to increase system performance and availability at the same time. Wait, better performance, making sure the systems are there when you need it? Well, how could you not want that in your system? Load balancers can reduce costs, and I'll explain to you how, but they can really help with scalability, and here's why. They can let you use multiple servers and make them act like a single server. And in many cases, it may be cheaper to buy more small servers than one giant server. But also, let's say you, instead of using a 256 core server, you had decided to use 8 32 core servers. Now, here's the thing. Now, if you use 8 32 core servers and one of those servers fails, you still have 7 left. But if you use a 256 core server and that fails, you got nothing. Like my grandmother would call it bupkas or dibata, depending upon which grandmother, have the Jewish one or the Greek one. So when you're in this position, the load balancer removes that single point of failure. Now, the load balancer improves scalability as why? Because, you know, I might need 8 servers, but if I need 9 servers, 10 servers, 11 servers, 500 servers, by using load balancers, I can keep spreading the load, and no one's the wiser. So I can allow a lot of performance, and at the same time, I can produce availability by removing single points of failure. So I love single points of failure. Now, how do load balancers remove single points of failure? Through a health check. Server 1, are you there? Yeah, I'm here. Server 2, are you here? Yes, I'm here. Server 3, I'm here. I got it. I love it. So kind of keep that in the back of mind. That's why we're using load balancers, to improve performance and availability. Now, load balancers, don't think they're new devices. They're 20 plus years old devices. And we love load balancers that typically fall into 2 categories. AWS has lots of names for them, but we either have network load balancers or we have application load balancers. I don't care what names you call them, gateway load balancers, they're one of 2. And network load balancer operates at layer 4, which means it looks at the TCP, UDP information. And network load balancers are fast. Why? They're not too bright. 2, 4, 6, 8, 10, 12, 14, 16, 18, 22, 24, 26, 28, 30. I mean, it's fast, right? Because they're not doing that much. And application load balancer is really smart. So instead of doing 2 plus 2 equals 4, now we're doing calculus in our head. Now, how fast can you do calculus in your head? My wife, pretty quickly. Me, I don't know how to do calculus. I'd have to learn. I could learn anything, but it wasn't something that I ever had to learn, so I didn't learn it. But the point is it would take longer to do calculus than it actually would to do not simple addition. So when we deal with application load balancers, we're looking at deep stuff inside of an HTTP or HTTPS header. Now, when we're on AWS, they have network load balancers. They call them elastic load balancer because their marketing people have to stick the word elastic in front of everything. And they also have application load balancers, for example, but they call them elastic load balancers too. And of course, they call a classic load balancer, which of course could be a network or an application load balancer. They call it a classic one. They recommend you don't use them. The same concept. So an elastic load balancer is a virtual load balancer instead of a physical load balancer. And it distributes traffic. Now, what's it distribute traffic to? Whatever you want it to. Typically speaking, virtual machines like your web servers. Now, the load servers are kind of auto-scaling. They kind of do whatever they need. They give you enough capacity. Load balancers can spread load across multiple availability zones. They support health checks, and they can terminate your SSL connection. So why is it cool to terminate your SSL connection? Well, SSL is a form of encryption. Encryption. And what do I mean by encryption? Encryption is running mathematical calculations. And let me tell you, mathematical calculations take CPU performance. And if you put these math calculations in the load balancer, where does this encryption not have to occur? On your web servers. So by offloading the encryption onto the load balancer instead of your web servers can be hanging out there like Cindy the cat, who's eating tuna fish, looking happy as a lark, relaxed, relaxed, relaxed. So that's why we love this. So AWS network load balancers route traffic based on network stuff. They can handle millions of requests per second. Excellent with rapidly changing conditions. And network load balancers, because they look at the TCP port, source and destination protocol and port number, and that's it. They're fast and they're stateful. Send this thing to server 1, goes to server 1. Next one goes to server 2, next to server 3. Third session's load balanced on server 3. And those connections stay until the connection is terminated between the users. They're stateful. What happens, they call it a sticky session that maps the source and destination of the connections. But it's by default on network load balancers. Now with AWS, you can put a static IP address on a load balancer. Well, we've been putting static IP addresses on load balancers for 20 plus years. And you can also route to containers, although when you're going to be routing containers, you're typically going to be using an application load balancer. Want to see what it looks like in action? Got a network load balancer, load balancing on high speed between 2 availability zones. Boom, boom, we're good to go. Now let's talk a little bit about application load balancers. Application load balancers work at layer 7 of the OSI model. And they look at the path provided in the URL, elements inside of an HTTP or HTTPS header, the HTTP routing method like push or get. They can route based upon source IP addresses. And these application load balancers are truly ideal for balancing HTTP and HTTPS traffic, ideal for balancing requests between microservices and container applications, optimal to load balance multiple requests on the same server by registering the same server on multiple ports. And they're pretty good for load balancing for those types of things. Now, how does this thing work? Well, in a similar manner, we've got our load balancer that's listening, and all load balancers route to something called the target group. But here we're dealing with much, much, much greater intelligence. Now, AWS is a classic load balancer. Guess what? It's the same thing. And it works on both EC2 instances, classics, and VPCs. Auto scales just like the rest of them. Provides the same cloud trail auditing. But they don't want you to use it. They want you to use the new one. It's called an elastic load balancer. Now let's talk about internal load balancers versus external load balancers. Internal load balancers are for your internal applications. Like you're not going to put your HR database on the public internet. An organization may have its private website called wwwin, which is pretty common for an organization, especially tech companies. They have an internal website called wwwin, which is only accessible for people inside of the network. So that would be an internal load balancer. An external load balancer, also called an internet-facing load balancer, is one that covers your systems to the internet. And the way load balancers work is they typically have a listener. A listener is a process that's going to wait for connection requests. Application load balancers are going to look for HTTP, HTTPS requests. Network load balancers by nature are going to look at a TCP or UDP request or a TCP UDP request. So let's talk a little bit about load balancer concepts. We've got targets. Target is where the application distributes its traffic. Targets can be a single instance or an IP address. When the target's an IP address, it needs to be from the private address space, meaning RFC19 address space or the shared address space. So when we're using elastic load balancers, we can only route to private addresses. So you're going to have private addresses in your web servers anyway, because the load balancer is going to be your public-facing address. So what does that mean, RFC 1918 addresses? Well, it includes the 10.0.0/8, the 172.16.0.0/12, the 192.168.0.0/16, and the 100.0.0/10 RFC 6598. That's what we're talking about. Now, I mentioned we can send to a target, but we could also create a target group. What's a target group? A group of systems. Now, as I previously mentioned, when we're dealing with load balancers, we can group our things to, we have the concept of sticky sessions. When we're dealing with sticky sessions, on the network load balancer, it's by default. But on the application load balancer, you might want to enable it. And if you want user one to stay on the same web server, we can do that through a sticky session. The way that'll work on a network load balancer is as part of the flow. On an application load balancer, they don't really have these kind of flows. So what'll happen is the application load balancer will give a cookie, and it'll use a cookie to track the session. And that's the way these work. Now, all load balancers use a health check. Are you there? Are you there? Don't get a response. Remove from the absolute rotation. Now, we've reached an interesting break in the content. And this is where we're going to do some voting. The next section is security, and it's a pretty big session. We could stop now. I can take questions for 15 minutes or so, which I think is probably the logical thing to do. Or we could potentially go for about 30 minutes and then do the rest tomorrow and on Friday. And actually, no matter what, we're going to have to go through Saturday anyway. So let's just answer some questions for a few minutes and call it a day. And then we have a big, fun, exciting day tomorrow.
All right. So as a reminder, everybody, we're just going to be answering questions that are related to the content that we're covering. So give me a few minutes to get you some questions, Mike.
Scaling up and scaling down based on instances for traffic. Where do load balancers and applications? There's got to be a second half to this question.
There is not.
Okay, I don't know how to answer that question. Edward, I'd love to help you. So perhaps answer your question a different way, and I will understand it, and I will be able to help you. How about ASG? Could you please translate ASG into what that actually means? I'm an architect. I don't use acronyms because ASG could mean about 10 different things to me. Hey, Mike, can the target be another load balancers? Manuel, absolutely. There are many cases where we need to use multiple load balancers. perhaps we need the intelligence of an application load balancer and the speed of a network load balancer. And we'd have to create a load balancer sandwich where we basically have a network load balancer fronting a bunch of application load balancer fronting in a bunch of containers. So yes, Emmanuel, that's a very common thing to do in load balancer architecture. Great question. How do you achieve on high availability on load balancers themselves? Great question there, Mauricio. Now, realistically speaking, in real load balancers, like the kind of cool stuff with the great feature sets we would get from, say, F5, they run a heartbeat kind of health check high availability protocol with them. But when we're on the cloud, if we're using the elastic load balancers, and there's times where we're going to need features that are above the elastic load balancers, and we have to go to the marketplace. But if we're going to be using the AWS load balancers, they're not real. They're virtual devices, not physical devices. And because they're not real devices, they don't break as long as the cloud goes down. So they're high availability as long as the cloud doesn't go down. And how do you protect yourself against the cloud going down? You use multiple clouds. Great question there, Mauricio. You guys are listening. Would you ever use proprietary load balancers? All the time. You might need the features and functionalities of a proprietary load balancer, and many enterprises do. So when they need real high-end load balancers, what do is they typically use a network load balancer and elastic load balancer to load balance between virtual, highly intelligent load balancers, the kind that are made by F5, if you're sitting on virtual machines. So there's 1,000,001 reasons you're going to need to use a lot of stuff from the AWS marketplace. In fact, I'm going to tell you, I don't think there's ever going to be an architecture ever where you can just use the stuff that's taught in your certification. You're always going to be getting stuff from the marketplace. Hi, Mike. How ELB ensure the server is alive to take the request? What happens if the ELB sends the request to the server and it's down? It won't do that. It's going to run a health check. So manual is going to be the load balancers every couple of seconds going to say, hey, server, are you there? The server is going to respond. Server, you're there, it's going to respond. Server, you're there, it's going to respond. If on the load balancer asks the server if it's there and it doesn't respond, it won't send any more traffic there. It'll either send it to a new available server or it'll just tell the systems that they're down. Good question, Mike. Okay, Edward, let's discuss the concept of scaling up versus scaling out. Scaling up is I've got a server that's got 16 cores, and I replace it with a server that's got 32 cores. Scaling out is I've got one server with 4 cores, I add a second server with 4 cores, I add a third server with 4 cores, a fourth server with 4 cores, so I add more. So that's what's called scaling out, and it's based upon systems, not really storage. When they talk about storage being scaling, it means they just allow you the flexibility to gain the capacity you need. Anakin ASG could mean autoscale group. It could mean one of 1,000 other things. And that's why the key critical skill for the architect and even the engineers is communication. Because when we communicate in acronyms, we create errors. People die. I've seen it. I've seen people use acronyms in medicine and somebody died because people didn't understand what they were using. I've seen, I recently had someone ask me and he says, Mike, how do I negotiate a higher salary? And I said, what do you do? And he says, VM. I said, you're working on virtual machines? And he says, not virtual machines. I said, you're working on voicemails? And he says, not voicemails. I'm working on vulnerability management. Now, how would anybody know that? And the point is making assumptions, assuming is very, very risky. So I will never make assumptions with customer networks. But it could have been that. Scaling up based on storage. So there really isn't a scaling up based on storage at all. What we're dealing with cloud is a little bit of agility and flexibility. So you filled up your 2 terabytes. It enables you to store 2.1, 2.2. It just grows on demand. That's what they're dealing with storage in the cloud. That's why we like cloud storage. Scaling out is based upon adding more systems, more services. with your new AWS book for the professional exam and then supplementing it with a series. Will that be enough for the professional exam? It depends on you and your test-taking abilities. It depends on how you learn. Personally, my recommendation is always as follows. Take ours, read the AWS white papers, and get a rock-solid practice exam. And here's the reason for the practice exam. AWS they're only challenging in their exam because the concepts are so easy, is the way they write these questions. And what I mean by calling it is I could give you tough questions like kind you would see in a CCIE environment that require you to think about each question, think about what they're asking you for an hour before you even understand it. Deep thought. These are pretty much straightforward multiple choice questions, but the way they write these questions in paragraph format, using the most complicated language they can and as many abbreviations and acronyms as possible, it's going to be really hard to understand them. The hardest part of the AWS exam is understanding what they're trying to ask you. So I recommend getting a practice exam. I will also say that I love Andrew Brown's Exam Pro certification stuff. Andrew Brown is a certification professional. He doesn't claim to be anything outside that. He's got a team of people that constantly look at certification curriculums and optimizes it. So I like to recommend Andrew Brown's free, along with all of our free. And Andrew Brown, if you upgrade the protocol from him, he typically has a practice exam, which is excellent, excellent, excellent. But many of you could pass the professional just with us on our book. Is it common to use a proprietary cloud load balancer in front of two application load balancers? Yeah, constantly do it all the time. But here's what's common or not common. Peter, it's not about what tech is right. It's never about the tech. It's what business problem are you trying to solve. Look, I had a customer, and we were able to save them a fortune by adding a second ice machine after watching what the people did and boarding back and forth to an ice machine. It's about whatever it takes to get the customer's business performance better as an architect. We'll constantly go to the marketplace for firewalls, marketplace for load balancers, marketplaces for everything. Of course, we can go to the next one. Does a load balancer basically work like a router? Not at all. Routers route based on destination IP address and run an algorithm to determine the best way to get your traffic through the network. And a load balancer distributes load across servers. So completely different in every way, shape, or form.
And just so everybody knows, we put a poll in the chat box for you guys and girls and cats and dogs. Let us know if you're ready for the security content tomorrow, or if you just can't wait for that networking boot camp.
Yeah, let us know. And before we get to the hashtag, while we wait for questions, I will share one thing that happened to me while I had lunch today. But let's make sure we have enough questions. Our load balancers basically instance specialized to do what they do. Well, Marion, in the real world, those specialty hardware devices. If we go to the marketplace, they are specialty software appliances that are based upon virtual machines, otherwise known as instances. And if you're dealing with the elastic load balancer, it's a software construct and a software load balancer that's part of any cloud. Any cloud you have will have their construct of a load balancer. Good question, Marion. Be sure to drop your vote in the polls, yes. And Chris, Jeannie, thank you so much. It's so good to see you. Vidik, it's wonderful having you here. Thank you so much for all your help and all your wonderful blogs that you've helped us with. Load balancers, kind of like traffic control. A container router is more like your GPS. Yeah, that'll work for me. And I want to get you all to give me a hashtag that says AWS Certified Solution Architect Associate. And while you do, I'm going to show you something hilarious that happened during lunch. Chris, be ready to share this video. It's only for 5 seconds, but I think it's cute as can be. So today when I was having lunch, my cat Cindy jumped on the table, and this is what she did for my water. Obviously, I got a new one. But I thought you would think
that's actually the only way Sunny drinks water.
It's the only way my cat will drink water. She refuses to drink out of a bowl. She only drinks out of a glass too. But I thought this was hysterically cute. If you've never seen a cat drink water out of a glass, my cat refuses to drink out of a bowl. She thinks she's human. She also gets fresh tuna and salmon cooked for her every single day, as well as shrimp and scallops. Because we can go back to me when you take my cat off. I just thought it was cute and fun. I'm loving it. AWS Certified Solution Architect Associate, good job. We're going to have fun with security. If you've not subscribed,
there's only been 65 votes so far.
Only 65 votes.
I don't think
Make sure you're awake, alert, and oriented. If you haven't liked the video, please do so. If you haven't subscribed and hit the bell, please do so. Yeah, the life of a cat at my house or Chris's house is not too rough. Collins, it's always good to see you. That's why you like dogs, just for the reason they jump in on the table. Your wife can't handle that. Yeah, my wife actually thought it was hilarious, so she's okay with it. Cindy has her own water glasses now, usually. Thanks, Jeannie. Lady Godiva. Cindy straight is chilling with Mike's water. Yes, she'll be doing it. Everyone, it was wonderful, wonderful, wonderful. It's always an honor and a privilege to have you here. You know, at Go Cloud Careers, we want to do everything we can. Obviously, the students in our Cloud Architect Career Development Program have access to everything, an extraordinary competitive advantage. But just being part of our YouTube channel, I want you all to have a better competitive advantage and get better training for free than anybody else's paid products. So please do anything we can to help you. If you've not downloaded the completely free AWS exam guide, please do so now. It covers the associate and professional exam. It'll be a big help with this. If you've not done your hands-on labs, this is great. Up and Up, you just passed the phone interview. Now you're ready for the loop. Good job, Up and Up. I definitely remember you. I know over lunch, another student of mine just told me they got their first cloud security architect job, which makes me happy all the time. So great to hear from you, Up and Up. We are thrilled to have you here. If you've not downloaded, practiced the lab, go get access to the labs. Again, they're completely free. And if you want to build your cloud computing career and become a cloud architect, we have our Cloud Architect Career Development Program, 30% off. Using coupon code SECURITY. If you've got an interview coming up, we've got an interview mastery program. Use coupon code SECURITY for 30% off. If you're already working in tech and you want to move into management, take our Tech Career Accelerator program, all 30% off. It's been an honor and a privilege to spend the afternoon with you. So thrilled to have you here. Please tell a friend to watch this free training so we can get as many people hired in the world. It's my goal to make sure that anybody that wants a cloud job can have a cloud job at the lowest cost possible. Thank you so much, Cloud Hired, and I'll see you all tomorrow. Oh, by the way, in the morning, they'll do some questions and answers about how to build your career and how to get hired if you like. We're doing that from what time? 10 to 11 tomorrow, Chris?
Yes.
10 to 11. Take care, everyone.